Let me, yeah.
Ja, alsjeblieft.
Like Hasselhoff, but not. Really close. Really close. Yeah, that's gonna suck.
Okay, so now you see your slides over there.
Yeah.
And if you have your speaker nose.
Right. So the problem is that none of my fonts are showing up. So that looks like ass. Like big monkey dung ass. Not good.
Oh, okay.
Fastest way is just to have you install the fonts on your computer and then open fonts.
Okay.
Should be. Are you connected to the internet?
Yeah.
On yours?
Yeah.
Should be loading the fonts. I gotta troubleshoot fonts. Yeah, I don't know if you can tell, but like, see the difference? There's a big difference between these two. Style sheet. Fuck. Shit. It's because they're local. So the fonts I have local are from Google. You can get them for free from Google. Can you do this? That might fix it. That might be the easiest way to fix it.
Okay.
Tangerine. Tangerine. And the other one is. Fuck. The other one is, Open Sans. Sorry. This is like not fun. Railway and Lato.
Can you install it to my computer?
Yeah, let's. mess with me today. Terrible. Too high up, I could see. Is it on? Good morning, everyone. How are you? Oh, okay, yay, that's better than I thought. I thought everyone would still be asleep. All right, so this morning we're gonna open up with another React talk from Sarah Veselov, and she's going to talk about how to style React. Sarah is a UI UX developer, UX lead at GitLab. And prior to that, she was a senior UI developer at Nitro Solutions and at Mad Mobile. She also serves as a director for Women Who Code and Girl Development Tampa chapters. So let's hear it from Sarah.
All right. Good morning. So I had some snafus with some fonts and some notes, so bear with me a little bit. But thank you for coming this early. So as you can probably tell from the title of my talk, it's based on some pretty painful personal experience. And I wanted to start today by sharing that experience with you. So in 2015, I worked at a small Tampa startup as a senior UI developer on a product team. And my main role was to build scalable, maintainable CSS architectures. The team and I had worked for months on a proof of concept. It looked a lot like a real app, but it was essentially vaporware. And we'd done well. There was a lot of buzz, and we'd snagged our first client. So it was time to get down to business and begin writing production quality code. It was an exciting opportunity to build an app from scratch, and we had decided we were going to do it in React. There's just one problem. There weren't any best practices for styling in React at that time. And this was really where the trouble started for me. Up until now, the team had been happy to take care of all the styles, to have me take care of all the styles, CSS, less, Sass. They really didn't care, as long as it looked good. But this all changed with React. All of a sudden, my 10+ years of experience styling applications meant absolutely nothing. And in fact, it meant that I was a dinosaur. And this was because in 2014, an engineer at Facebook gave a talk that changed everything. His talk made the case for putting CSS in your JS. And this really represented a shift from traditional MVC architectures to a more component-based architecture. And that shift changed the way we viewed styling in relationship to the rest of the code base. So the next few months, honestly, were some of the worst of my career. Every presentation, every conversation became a confrontation. Every conversation became a confrontation, and it was meant to shame and bully one side or the other into seeing the error of their ways. And by the end of it all, none of us were friends anymore. So if this sounds crazy, it was. And if it sounds familiar, I'm really sorry. But it didn't have to end this way. The team imploded not because of bad technology choices. In reality, most of the styling choices we tried would have worked if we just stuck with it. The problem was us and the way we approached the problem. We'd made things far more complicated and personal than they needed to be. If we'd been asking the right questions and really listening to each other, we could have avoided the whole mess. That was 2 years ago. A lot has changed. But the debate really hasn't. This is a recent Google search I did just for CSS. So I see the same arguments being made today that we were having 2 years ago. So I want to talk about that today and take a look at both sides of that argument, and then look at the pros and cons of each way that you really can style in React. So I'm going to look at both sides of the debate, starting with the gripes against CSS. We all know CSS is broken, right? CSS uses global scope by default. That is a no-no in JavaScript. Why are we doing it in styles? CSS dependencies and inheritance make style collision and overriding just inevitable. You're looking at separation of concerns all wrong on the CSS side, right? We look at CSS separation of concerns as a separation of technologies. And in CSS and JS, it's really a separation of components and what each piece is doing. And then the cascade, of course, causes thousands of lines of dead code and doesn't work with CSS at scale, so you have this dead code problem. But there are equally strong gripes against CSS and JS. CSS isn't broken, you just don't know how to use it. Using JavaScript to create CSS is excessive and unnecessary. Why are we reinventing the wheel? CSS works just fine on its own. CSS should be separate from your markup. The cascade is your friend if you know how to use it. And of course, oops. Apologies there. The cascade is your friend if you know how to use it. And of course, inline styles are a hack. So both sides, CSS and JS and the CSS side, have some pretty serious concerns about what the other side is doing. So now that we've heard the two sides, let's look at the options. You can break down styling into 4 basic categories, each one with its own sets of pros and cons. I'm going to start with the basics. Standardization methods, otherwise known as naming things intelligently. There are a lot of methods out there. Common thread among all of them is to eliminate style collision by lowering specificity and encouraging modularity. So standardization methods work with CSS, Sass, Less, you name it. And in 2015, BEM was a standardization the CSS camp on the team was rooting for. And BEM stands for Block Element Modifier. Rules are really, really simple. Everything has a class, everything. Elements should never be directly styled, no nesting of styles. And choose clear naming conventions. And of course, you must follow the syntax religiously. So in this example, I have my friend component. Friend is a block. It's a standalone entity that has its own meaning and identity. Any DOM node in my friend block is an element of that block. They are semantically tied to that block and have no meaning on their own. So you would never use friend image or friend name or friend description anywhere else in your code base. It should always live inside that friend block. And a modifier is just an extra class name that can be added to blocks and elements to change its appearance or behavior. Modifiers should only modify the block, never replace it. And in terms of component structure, here's a simple component folder structure to start with. And I'm by no means telling you this is the way to do it. This is just one way that you can do it. I think component folder structure and structure in general is very personalized from project to project. But here we've got this simple structure. Each component should do one thing and do it well. And notice that each folder contains the JS, CSS, and test files. In this example, components have been broken out into two categories. So we've got our container components and just our components. The components folder represents our presentational components. They're stateless and they simply take props. The container components are stateful. They make API calls, et cetera, et cetera. There's a lot of benefits to this approach. You get better but different type of separation of concerns, and you get reusability in other projects if that's something you're concerned with. The presentational components also can be worked on by the design team without concern that it's going to affect the app's logic. So there's a lot of pros to BEM and standardization methods in general. I think they're a natural fit for building components. There's no configuration, compiler, etc. So we're using just straight CSS. Nothing to configure, nothing to set up and put together. Using BEM and presentational components, each component can be used over and over again in other projects. And single class names make collisions impossible and easier to rework as long as everyone's following that syntax. Rendering engines evaluate CSS selectors right to left, so the less there is to evaluate, the faster it's going to render. And I think that BEM structure lends itself perfectly to linting, so you can make sure that every style that is added conforms to the same standards. But there are some cons. Let's face it, naming things is really hard. It's probably one of the hardest things that we do. It sounds crazy to anyone that doesn't do this for a living, but I think most of my time building CSS architectures has been figuring out what to name something so someone else knows what I'm talking about. The rigid structure of BEM is what makes it work, but it's also, I think, what makes it difficult to write at first. It feels really weird. It doesn't feel natural, and when something doesn't feel natural, it takes longer. So it can be really frustrating to do something that you think you could do a lot faster another way, but you're being forced into this syntax and into this particular method. So you got to get team buy-in in order for this system to work. And losing the benefit of the cascade can be seen as a pro or con, depending on which side of the debate you fall on. The cascade can keep things dry when used correctly, or can result in a bloated code base where styles are repeatedly overridden and hacked. It's possible to use BEM for theming, but I would say that there are far better methods out there if theming is something that's important to you in the work that you're doing. And it may not be a serious con, but something about the underscores and the dashes when you first work them feels really, really ugly. And again, I think it goes back to writing something that's difficult or doesn't come naturally can make things a lot slower. So next I want to look at preprocessors. We're turning this into that. So a CSS preprocessor takes a language and outputs it as CSS. Syntax is usually more readable than plain CSS and allows you to write dry code faster. They contain a lot of helpful features like variables, operations, mix-ins, you name it. I think Sass is probably one of the most well-known extension languages, and so that's the one I'm just going to touch upon here in this talk. So the bad news about Sass, or any preprocessor, is that you still need to name things. So in this example, I'm continuing to use the BEM naming convention for our friend component. The friend component will look exactly the same as in the last example. Nothing changes here. The component itself is set. The difference here is that instead of having to write out each class in its entirety, we're nesting using the ampersand to assemble each class. We have variables in here, and there's a lot of ways that I could dry this up even further. Once compiled, the CSS output is going to be exactly the same as in our original example. And again, with the folder structure, nothing has really changed. We're still approaching each component as a whole entity. We're no longer separating HTML, CSS, and JS, and instead we're separating based on presentational components and container components. And in this example, I actually have the Sass outputting to an individual CSS file that lives within the component. However, you can do it a number of different ways. You could compile this into one style sheet and load that whole style sheet instead. So pros. There's a lot of pros to preprocessors. Sass gives you the power, obviously, of variables, mix-ins, nestings. It's got a lot of really helpful features I think a lot of us have grown dependent on. And in general, you can dry up your code quite a bit using these features. I also think a lot of them are really easy to pick up. If you already know CSS, there's no real overhead to jumping in and working with Sass. You can really do it straight away without much help. And similar to a first setup, each presentation component is modular. Each Sass file can be compiled into one sheet or can be exported into one single CSS sheet that lives with that component. So it really lends itself to working for your team and for the project the way you need it to. There are some cons. So to use Sass in your project, you'll need to add some configuration and dependencies. It isn't really a big con considering what we already do with Webpack and other things in React, but it's something to keep in mind. It's just one more layer. Nesting can get out of control very, very quickly. I've seen some devs new to Sass nest themselves, I mean, like straight to hell. They're like 10 deep and they can't figure out how that possibly happened. So you've got to be really careful with Sass and nesting. Having said that, I would argue that the component composition of React in general reduces the need for mix-ins and nesting. You shouldn't be building these really big components that do a lot of things. They should be very, very small. They should be very, very concentrated. And the amount of styling you need should be relatively small. So you may not even need those things. And you have to name a lot of things, right? We just don't want to do this. It seems to be a really popular refrain. So now I want to talk about inline styles. And inline styles are not the same as CSS and JS, and I'm going to get to that in a minute. And the first two methods that we just talked about have been standard for quite a long time. Adding CSS styles inline goes back even further. But in 2015, the idea of using them to style your entire application seemed kind of crazy. So just like it sounds, inline styles attach your styles inline to the actual DOM node. And again, they're not the same thing as CSS and JS, and I will get to that. But this is a same friend component. It's a simple example of inline styles. And this was the first example that the CSS and JS folks on the team brought to us in 2015. And I gotta say, we were horrified when we saw this. And to be fair, this is not how most people are using inline styles. Most are using style objects. It's much more maintainable than the first example. It's also the way React Native handles styling. Most will take it one step further and place the style objects in a separate document and then import that into the component. Sound familiar? Should. So, at the time, the thought for many of us was, seriously? You want us to style an entire application like this? The very thought of styling an entire app by injecting styles seemed laughable at the time. Because a big argument, right, had been working with CSS at scale. And from the perspective of the CSS folks, this was not scalable. The font size, color palette of the application had changed several times in just the few months that we were working on the proof of concept. How are we ever going to manage monumental style changes like that with inline styles? Surely there was an obvious need for global styles to handle things like font sizing, vertical rhythm, and color palette. Even more distressing at the time was learning what it couldn't do. And the main difference between inline styles and CSS and JS. So inline styles only supports a subset of CSS. CSS and JS, on the other hand, allows you to use all the power of CSS because it generates actual CSS. And we're going to get to those in a minute. I know I keep saying that, but we're almost there. So while inline styles are lacking quite a bit, I think there are some positives to them. Inline styles really forces you to change your mental model and see each component as its own entity. And this was something that it really did for me. I will admit that I was not against the idea of CSS and JS, but it did go against everything that I had learned, my years and years of best practice, and it really put my hackles up. But sitting down and writing a component and using inline styles really changed my view on that. I was able to see the component as its own concern and see the value in being able to localize those styles. And obviously, inline styles are the trump card in specificity, right? There's no way someone's going to accidentally override them or leave unused styles hanging around. And if you intend to stick with React long term to go React Native, your styles are still going to work. It's going to be much easier to move those over. So the cons list is a bit longer. So you'll need to depend on a library to access basic CSS features. And this was one of the big arguments from the CSS side at the time was we're just adding all these things that CSS does naturally. Why would we do this? And if you're not using a library, it's necessary to program JS workarounds to address media queries, pseudo-selectors, all of the things that CSS gives you just out of the box. And then again, depending on which side of the debate you're on, you lose the cascade. So you're not able to make global style changes using the cascade. Every component would need to be touched if the changes were going to be to go across all the components. And I got to say, it was really difficult to debug in the DOM. I did most of my work in the inspector, and when you're not using mapping class names to the elements, it's really difficult to tell what you're looking at. Even when you know what you're looking at, it's difficult to tell what you're looking at because the styles are jammed in with the rest of your elements. And interestingly enough, the components themselves don't really lend themselves to outside use in other code bases because you're placing these styles directly in line. You'd have to go in and reconfigure basically every single one by hand in order to use it somewhere else. And another interesting thing that we found was that performance was not very good. A page full of inline styles where each tag needs to be parsed is going to be less performant than loading a single style sheet. So CSS and JS is pretty hot right now, but in 2015 it was on fire. And in 2015, there weren't a lot of CSS and JS libraries, aside from Radium, CSS modules, and I think at the time that we were developing, like Aphrodite had just come out. Many of the cons that were plaguing inline JS could also be applied to libraries available at that time. And I think it's evolved quite a bit. So style components weren't around in 2015, but I think that they represent a giant leap forward in CSS and JS libraries, so I'm going to talk about that today. So here we have our same friend component. Should be very familiar with this component by now. But there's a big difference in the way we're putting this together. So style components actually utilizes tagged template literals to use real CSS and create normal React components. So as you can see, we're importing styled from style components, so we're importing that library, and then we're able to construct a wrapper component that applies the styles to a section tag. So wrapper equals style.section. In the DOM, that's actually going to generate a section tag with a mapped class name that maps to those styles. So it's a big difference in the way that you handle inline styles. It is not inline. It's actually generating a CSS style sheet. So at runtime, it's actually loading that into the head section of your document and then applying the class name to the styles. So I would say that how you structure your component folder is going to be a team decision, and in most cases should be decided before you ever touch the styles. In this example, I've actually broken that component down even further. Here, the way we've broken it down is we've constructed each piece, and then I'm just building in my render each piece of that component. Here, I've actually broken out each one as its own separate entity, and I'm bringing them into my index file. And that way, I can use these over and over again in other components and other areas and build like a bunch of Lego blocks, really. So this allows more flexibility and scalability long term, as you can easily move those smaller pieces around to construct larger components. So I think style components have a lot going for them, and CSS and JS libraries in general do. They allow you to write real CSS without context shifting between JavaScript and a set of style sheets. And it also enforces CSS best practices by removing that mapping between the HTML and the CSS. Because you're building small, purely presentational components, they're independent and reusable. And single-use class names make, there we go. Single-use class names make naming easier with no chance of collision. And of course, you have your containers and components, so you're separating out your presentational from your logic. Style Components actually has basic Sass support, so you can do things with variables, nesting, mix-ins. There's a lot of really cool features there. It even has native mobile support and theme support. So there are some cons. Choosing CSS and JS as an approach means choosing a framework. So it's one choice followed by another choice. Glamour, Style Components, Aphrodite, CSS modules. There are many flavors of CSS and JS out there. And at the end of this deck, I actually have a resource that takes you to an entire list of all the possible CSS and JS choices you have. And it's yet another library to use, which I think is something to keep in mind because things change so quickly. Relying on a library that's the hot new thing today might be a problem later on. And it's also something that needs to be understood by the entire team. And I think a solid case could be made for the complexity this introduces. Many teams have designers and implementing styles and design patterns in CSS. So while a developer might be able to jump right in and feel very comfortable because this utilizes so much of what's already there in JavaScript, it could be difficult for others on the team. So the question is, what should I use? It depends. I know you're looking for one answer today, but there really is no one answer. I think it really does depend. There are a lot of choices out there. I think you need to start by asking the right questions. So what are the mental models on the team? A mental model is based on belief, not facts. It's a model of what users think or what users know or think they know about a system. And understanding each person's mental model of styling can help clear up misunderstandings and foster productive conversations. I think really having a good idea of how each person sees styling so that you can speak to their view on it a little bit better can help you in those conversations. And I think it's also important to acknowledge the differing skill levels on the team. So if there's a mixture of skill levels, as I said, a lot of times you have designers that are implementing your CSS and may not be as comfortable in JavaScript. Simplicity and clarity can really help everyone stay together. And if you're a group of highly skilled devs, then I think introducing complexity or new technologies probably won't pose that much of a problem. And then what do you need to build? Make sure you understand what you actually need to build. There's a lot of pressure in our industry to know the latest framework, the latest language, or whatever tech is making the rounds today. And it can be really tempting to jump on the latest technology. So before adding libraries and building complex styling systems to accommodate theming and reusability, make sure there's something you actually need. Start out as simply as possible and build from there. And then how do you plan on structuring your project? React is not opinionated about project structure, so understanding how you want to structure your project is going to help you determine the style method that's going to work best for you and the rest of your team. Will container components live separately from presentational components, or are they going to be kept together? Will you have the need for access to global styles? Is that something that you anticipate having to have? And these are just a couple of considerations. So think about these things before you jump into making that styling decision. Even more importantly, I think, is to create the right environment. Building things successfully requires more than the right technology. It really does require the right environment. And I think there are 4 ingredients to making that happen. First, avoid dogma at all costs. Taking extreme positions on a subject creates tension and defensiveness before conversations even get started. Build trust. Taking risks is really hard to do, and it's even harder if you don't trust the people you're doing it with. I think you need to embrace change. Whenever you feel the urge to push back on something, lean in instead, and you'll be surprised at what you'll learn and how many friends you're going to make along the way. I think lastly, you need to be vulnerable. It's okay to say you don't understand something or that you don't see the benefit in it. Being honest builds trust and opens the opportunity up for greater understanding for everyone on the team. And I think it's also important to remember, I love this quote, having a thoughtful understanding of CSS to begin with is going to help you build greater things. So whether you do it using CSS, Sass, Less, or CSS and JS, understanding what you're building and how to use it is very important. Thank you.
Thank you so much, Sarah. I think I have just one question for you. So you mentioned, how to style React components is a very divisive topic. Mm-hmm. And you evaluated all pros and cons for different methods, which are great tools to have to convince team members. But what if you have to work with someone who still does not agree with you? What do you do? Like, how do you still not lose friends that way?
Well, not everyone's going to be your friend, right? I think at that point you have to agree to disagree, but commit. So whether you agree with that decision or the other team member agrees with that decision, as long as you all commit to making that work and moving forward with it, it's going to be just fine. It's all going to work. It's the best way.
Okay, so just first acknowledge that not everyone can be my friend, and then just commit to my decisions. Okay.
Commit to that decision and just keep going with it. Otherwise, you're just going to keep going round and round and refactoring, and it's going to be a mess.
Okay, that makes total sense. All right, thanks a lot.
Thank you,
Sarah.
Thank you.
My mic is not. We have, I was just going to say we have time for a break, actually.
Yeah, 9 minutes.
Yeah, can I?
Okay,
Hello.
Sorry, 1 second.
Get out of your way.
Would you agree? We have the same colors on our slides.
Is this one working?
I don't know.
Hello. Okay. So we actually have time for a small break for 8 minutes. There's like a small scheduling change. So the second talk of the other track was canceled. So the original first talk will be moved to this slot now. So if you want to go over there to catch that talk, that's totally fine. Otherwise, yes, stick here for another 8 minutes and then we'll have the next talk ready. Just make sure your name is Catherine.
Mead.
Mead. Okay. Yeah.
page is going to be on that screen and the other one will be on my laptop screen.
It's not okay to have it duplicate. Is that okay for you?
Yes, that.
Yeah.
Oh, you have it down here too? Yes. Are these going to be different?
No, no, no.
I can put my speaker notes here.
No, no. Yeah, yeah. This. Yeah, sorry.
So this is my speaker notes, and
Okay.
this is what goes on the screen. So this is on my laptop, and this is on the big screen.
Okay, okay. This two screen is just the same one going to the
Okay.
projector. Sorry.
I'll stand
Okay,
here.
can you
then.
set this on full screen?
Okay. Am I messing stuff up for
Yeah.
you?
My ma'am just needs on my phone.
Yeah, it's in the.
Beautiful.
Okay. Yeah, yeah.
It's an F. You just hit the F key.
Okay. Have you a full white on this screen? Can you have a test slide or something?
What do you mean?
One second.
Yeah, the edges of my slides are cut off.
Okay. Let me know if you have a delay.
It's okay.
Can you set this photos in full screen? We will go back. We can find them out. Go back here. Maybe this one. Oh, sweet. What? Wait.
Any of these will work?
I just need full screen photos so I can.
Play with it.
No, it's not 69. Maybe this one.
This one?
Yeah.
This one?
No, this one.
This one? You like this one? Why did it do that?
Can you open your slides again?
Hold on.
have 3 slides a little bit off. Is it okay for you?
Yeah, is the first slide okay?
Yeah, first slide and this one. There's 2 here.
Okay.
Yeah. Okay, do you like to have a wireless mic?
Yeah. I think it might be on. Yeah.
Yeah.
Maybe. Is this on?
No, just. Okay, are you ready?
Hello. You good? All good?
I think so. Yeah.
Hi. So, you know, like sometimes when big companies or brands say something really ridiculous on social media or something, and people call it, this brand is totally having a PR nightmare. So, for example, just a few weeks ago, KFC ran out of chickens. And 600 out of 900 of their stores across Britain were forced to shut down. So, of course, there was hashtag KFC crisis trending on Twitter. Anyway, people call it a KFC PR nightmare. And I was like, wait, what the hell did KFC do? Did they make a giant pull request with 500 change files and a description only reads, fix a thing? Well, it turned out PR nightmare meant public relation nightmare, not pull request nightmare. Otherwise, they should totally tune in next to listen to the next talk where we have Catherine Mead teaching us how to not have pull request nightmares. Catherine works at Sparkbox. She has a strong passion for education. She spends a lot of her free time volunteering and teaching with girl development. Her other hobbies include reading, video, and tabletop games, and making cat jokes. So without further ado, we have Catherine.
Hi. Is my mic on? Can somebody give me a thumbs up if you can hear me? Because I can't hear. Okay, great. That works really well because I can't see you. Anyway, so the first letter on this repository link here is a T. I will share it again. I also tweeted it out. My name is Catherine Mead. I work at a company called Sparkbox. I'm a full stack developer, whatever that means. I use she, her pronouns. Sparkbox is a little web shop in Ohio. We have about 40 people. I spend most of my time working on an enterprise level design system. You can ask me about later. So today I'm going to share with you a few tools and techniques to make your pull requests more effective and more collaborative. Because of time, I hope to do a quick summary of a few tools, and you can Google them later after the event. Most of these tools are not GitHub exclusive, so I've met people from GitLab and Bitbucket here, and I know there's at least one GitHub person. So hopefully, you still find something even if GitHub is not your main technology. To start, I should share a bit about context and how Sparkbox does code reviews. We store nearly all of our code on GitHub. We do have one Bitbucket client now. That's kind of new. We use shared repositories dedicated to whatever engagement we're working on. Whenever developers have new code to add to the project, they ask another developer for code review via pull request. I've come up with 6 sort of rules that Sparkbox adheres to while using GitHub, and I will just say that I came up with these rules for the Sparkbox process, so I do not represent the thoughts and ideas of my employer. Rule number 1 is no one merges their own code. Sparkbox likes to avoid the concept of a developer island, where one developer is writing and merging all of the code for a piece of a website. Last year, we had a client who wanted an additional full-time developer for a side project, but they would be the only developer on that project. We offered instead 2 developers at halftime. Having a reviewer is that important to us. The second rule is never push directly to master. Pushing directly to master is the easiest way to break everything. Requiring a code review reinforces the quality that we've come to value as a company. Third rule, if you're working with UI, get a design review. At Sparkbox, we have a position called a front-end designer. On every project we design, this special designer often will write front-end code, so they may do some CSS. But not every company has designers who know how to code, and nor should they, but that's probably a different talk. Rule number 4, if you are working on copy, get a copy review at Sparkbox. This is usually the project manager or the client themselves. We have an integrated development process, so the clients usually have access to the repositories we're working on. Rule number 5 is never, ever push directly to master. Again, unless you messed up, which if you did, find a buddy to pair with. Which leads me to rule number 6, which is these rules are more like guidelines. And I made them up. But if you follow these 6 rules, it ensures that we follow the basic Sparkbox creed, which is working together for a web built right. If every piece of code has at least 2 people contributing to it, we often catch mistakes before they happen. So all of that is context for what I'm about to talk about. It may be different for you and your company. It's just how we like to work. So I'm not telling you how you should do code reviews. Some challenges of collaboration are getting a PR review from a non-coder or getting a PR review from someone who's in a different time zone. Currently, I am 5 hours separate from most of my team and 9 hours separated from the rest. It's not that easy. Working with developers who may be only doing reviews on your project or working with people who are assigned directly to PR review and nothing else. So how do we improve these things? So I'm going to give you 6 steps, I think. I guess I like the number 6. Tip number 1 is write good stories. To ensure good pull requests, we have to write good issues. At Sparkbox, we often use ZenHub, GitHub Projects, Jira, or Trello to organize engagements, usually with something like Scrum, which involves creating stories, which is usually a GitHub issue, representing a bite-sized chunk of work. So let's hope these pictures work right. All right. Stories should include the requirements of the work and potentially a solution if you have one in mind. Story or issue doesn't need to be overly complicated, but it should be easy to understand. A well-written story makes for clear requirements when it comes time to do a PR. And this leads you to my very first tool recommendation. The only one that is GitHub exclusive, but I'm sure there's something similar on the other technologies. Just for reference in the photo, this is my coworker Austin, who is a project manager, explaining that this footer is not great, so maybe we can use some of these other colors instead. So GitHub issue templates and PR templates allow you to add a markdown file to your root directory to outline the issue process. I'll share this link again in a minute. This is an issue template. Here's my markdown. It's included directly in my project. Button. In addition to adding the template file to the root of your project, you can also include it via .github directory. PR templates are also a thing that can go in this directory. They work the same way but have a different file name, and they come up when you do a PR instead of an issue. So here is the issue template on GitHub. When I click the new issue button, the text field populates with the contents of the template file. And then these example files are stored in the repo. I linked at the beginning, and I tweeted out, and I'll link at the end, I think, if you want to take a closer look. Talk with your project team to decide what you should put into a template. Mine is just an example. It's a very flat example. But a checklist is usually nice, so you can go through and click things off. So there's that link again. I'll give you about 30 seconds, 3 seconds, 2 seconds. All right. Tip number 2 is get the basics right. A good way to frustrate your pull request reviewer is to send them something with absolutely no context. You could respond in kind. These are real PRs, people. From my coworkers, they're great. But a few extra minutes to write a thoughtful PR description can go a long way toward easing the work of the reviewer. We try to include a quick summary of the work being done, usually matching your commit descriptions. A link to any GitHub issues or stories, especially if you're using something like ZenHub or Jira for Agile. A link or screenshot of the original design work if you're working on UI. As a developer, I love screenshots in addition to design files because I don't have to open up Zeppelin every single time I'm looking at something to build. And step-by-step testing instructions, including how to run the linter or how to run the tests, how to navigate to any new work, how specifically your new work is meant to function. So here's that PR example again. This is from my other coworker, Brian. He's hit a number of these tips. They should be written in the context of the developer reviewing the work. For example, a PR to a developer who's only doing review or QA may look completely different to the one who wrote the build process. All right. Next tip, enhance your pull request with GIF. This is my favorite GIF because it's a cat, and the cat is coding, and my name is Kat, and I'm a coder. So it's me. I hope you like that joke. It's my only one. So what if a GIF can be more than a quick laugh? GIFs are awesome for showing nav functionality, transitions, hover effects, animations, pretty much any visual aspect of your work. We're a front-end shop, can you tell? GIFs are especially useful for getting a design review of an animation or hover from someone who may not have the site running locally. Here is my tool for this one. It's called Recordit. There's the link, it's recordit.co. Recordit is a screencasting service that lets you save your finished recording as a GIF and even gives you a hosted link. An example use case is the Foundry, which is a Sparkbox blog. The CMS that this Foundry is built upon is a really big deal to set up. It may take a full day, especially if it's for a designer or project manager who's just trying to review 1 or 2 lines of code or content. By including a GIF, you may give the necessary context and allow everyone to feel confident in what they are approving. So this is just a GIF I made of some functionality. So here's the link to Recordit again. A downside to Recordit is that it doesn't currently support HTTPS, which means, as you may know, that it can't be embedded directly into a PR on GitHub. It can still be sent as a Slack link or just in an email or whatever. An alternative, I've recently discovered GIFOX. GIFOX is a native app. It creates GIFs, and you can drop them into GitHub to host them just like you would an image. Hosting on GitHub gives you the full security of your repository, so you're not violating your security policies. It does cost $5. Wow, this one's really off. It is included in SetApp if you're a SetApp subscriber, and I think this one only works on Mac. But there are lots of GIFing tools out there. It's sort of the thought that counts. All right. The next one is enhancing your pull request with video. An important aspect of a complicated PR is the ability to walk someone through your code. In the current age, devs are often distributed or remote. We work in different time zones and have busy schedules. Sometimes it is nearly impossible to schedule the 30 minutes to step through your PR. Here's the tool. It's GoVideo by Vidyard. This used to be called Viewdit. They changed it right after I wrote my talk, so I had to change it. GoVideo is a Chrome extension. They also have a native app because not everyone is a fan of Chrome. Hello, Mozilla. GoVideo lets a user record their screen, their face, and their voice all at once. Specifically, we used a video project like this on an engagement where the main reviewer, me, was not dedicated to the project full time. Because I was not available for stand-ups, I didn't have a direct hand in building the website, and I wasn't really familiar with the changes being reviewed. The dev had to explain every change for every PR. GoVideo is one of my new favorite ways to start a code review. I've made you a video instead of showing you how it's done. Hopefully it works. I keep meaning to re-record this, but people tell me that awkwardness is endearing, so just go with it. Let's hope the sound works. Yeah.
Hey there, GitHubbers. This is Go.
Can you hear that? You can't hear that. Oh, there's an audio cable. I should have told you, huh? He's like, yeah. All right.
Hey there, GitHubbers. This is Go Video by Vidyard. As you can see, it records my entire screen, plus a little me down in the corner over here, hello, that I think is super friendly and great for doing video walkthroughs of pull requests. Here you can see that I am on a pull request, and I can go into my file changes. I can look at the code. I can explain, hey, this class adds 3M of padding bottom to our Sparkbox homepage. It hopefully fixes an issue. I hope you like it. Please merge it. Obviously, I did merge it because this is me. And then when you are done recording your video, you can go on to a screen. One shows up like this. You can see that you can change your title, like Kat is super great at videos. You should try it sometime. It's not that great. Just kidding, that's a bad joke. So you can change your thumbnail, sort of scrub through contents, and when you're done, you get a link right here. That link is HTTPS, so you can embed it directly into your pull request, and whoever wants to review your code gets a nice friendly walkthrough, and it doesn't matter about time zones or anything fun like that.
All right, never again. Thanks. That's really encouraging. So here's the link again. Depending on the size of your PR, a walkthrough video only adds about 5 or 10 minutes total to our setup time, but it can potentially save the 30 to 60 minutes it might take to explain your PR via Slack or email, or scheduling a Zoom meeting. This is especially useful when pairing developers who have different schedules, who are remote or who are not as familiar with the engagement you're working on. All right, 2 more tips. There's another give valuable feedback, Skitch. Skitch is a free app. We're going directly into the tool here. Skitch is a free app from Evernote. It's probably my favorite thing on all of these slides. It is loved by Sparkbox for everything from full-page decomps to quick design edits to making memes of your coworkers. I use it daily. Here is an example. I just made this up. Skitch provides elegant markup tools for drawing boxes, adding arrows, and highlighting any necessary changes. You can just take a screenshot and have at it. That's Shift-Command-4 on a Mac. It took me a really long time to learn that, so now you don't have to pretend you didn't know. So here are some real-world examples. I pulled these directly out of Slack. Just going to go through them. Oh, that one doesn't work. Here's some muscles. This is the best joke in my slides, and it's not even mine. All right, so that's Skitch by Evernote. You can just Google Skitch. You don't have to remember this whole link. Skitch works well in the opposite direction of Record It. It's an easy way for designers to communicate desired changes with developers. Say, make this bigger, reduce the space here, delete this link. Skitch provides visual feedback for visual thinkers. All right, last one. One last way to make your PRs friendlier is to be friendly. Spat via GitHub comments is no way to collaborate, and let's face it, we know communication is very difficult in text. It doesn't communicate tone. That's why we invented emoji. A coworker of mine, Brian, the one who wrote the really awesome PR earlier, also wrote an article about this topic. It's called Stop Giving Depressing Code Reviews. The idea is to give as much possible positive code feedback as you do correction. It's really hard, especially if you're an INTJ like me. You just go through and see all the negative and you don't offer any positive comments. But you can do it. So this is a picture of Brian. He knows I'm including it. Instead of really going to this topic, I'm going to read you this quote. It says, "Giving positive feedback is an easy habit to adopt. You're already reading through the lines of code, looking for issues. It doesn't take much time to throw in a nice or looks great. If you see something awesome, say it. So the link to the full article is there. But a few positive comments make a huge difference in the overall tone of your review, whether you're speaking with designers, developers, other team contributors, clients, which are really important. So yeah, be nice. And that's what I have. Hopefully at least one of these tools can make the PR experience more accessible for your entire team and not just the developers. With healthy dose of empathy, we can improve the way our coworkers review the code we write, and as a result, we create smoother workflows, increase both speed and communication, and make better websites. If you want to hear more about Sparkbox or the design system I'm building, please come find me. I have decals and some business cards that look like ninja stars up here at the front desk, and that's it.
I'm going to make everyone eye on board from now on to watch this talk. That was really good. One question: if you were to make a large feature and you know it's going to be big, at what point do you open up a PR? What do you think of work in progress PRs?
I love work in progress PRs. The minute I have a commit, I open a PR so people can see my work in progress. We, on all of our projects, have a work in progress label we throw on there, and I really love being able to do WIP commits as well. So if I make a change to a large body of work, I'm actually going to write a blog post about this stuff. Hopefully it comes out in the next few months. If I make changes to work people have already reviewed, I like to use a WIP commit and then do an interactive rebase to squish them down at the end. But it makes it easy to track the changes.
I absolutely
So
agree.
Immediately.
Yes. Okay. I'm also a work in progress PR fan. So, a round of applause for Catherine. I think we're a little bit early, so we have a good 20-minute break and go use a washroom or grab some refreshments or whatnot. We'll be back here at 11:20. Does anyone know who Harry Houdini was? Really? Because I just learned about it today. So, he was a Hungarian-born American magician, noted for his sensational escape acts. He first attracted notice as Harry Handcuff Houdini on a tour of Europe, where he challenged police forces to keep him locked up. Soon, he extended his repertoire to include chains, ropes slung from skyscrapers, straitjackets underwater, and having to escape from and hold his breath inside a sealed milk can with water in it. Now, what does that have anything to do with the next talk? Absolutely nothing. Aside from the fact that it's about CSS Houdini, and I do not know anything about it, so I'm just rambling and reading Wikipedia article about Harry Houdini. So I think I should stop doing that and introduce our next speaker, who's hailing from New Delhi, India. Arun Michael D'Souza is currently working at PushUp on various EdTech-related technology and products. He is an open source enthusiast and has released several utilities and library for AngularJS, Node.js, JavaScript, Sass, etc. So let's hear Arun talk about CSS Houdini.
Thank you so much, Vanessa, for the introduction. I hope I'm audible to everyone. Okay, so let's start. So yeah, about me, my name's Arun, like you all know now. I've come all the way from New Delhi, India. I work as a software engineer by profession, mostly work with web technologies, full stack JavaScript to be exact. And like Vanessa said, I'm an open source enthusiast. I've released several open source projects and contributed to several other projects, including some Node projects, some Angular projects, Sass, CSS, and all that stuff. I'm currently working at PushUp, which is an ad tech company based out of New Delhi. So we help web publishers optimize their ad revenues through advanced A/B testing, layout optimization, as well as demand optimization. So if you want to know more about us, you can simply check out our website. It's www.adpushup.com. So about Houdini, what is it, and why is it so important to talk about? I think before we understand what Houdini is, we need to understand the history behind it, what actually led to the creation of Houdini. And of course, as web developers, how does that help us? I must mention that this is going to be a bit of a technical talk, so we'll be seeing a lot of code here. But before we begin, I want to know how many guys have read about Houdini or maybe have experimented with Houdini before? Okay, few people. That's great. So you guys might be wondering why I'm talking about CSS in a JavaScript conference, right? I mean, it doesn't make any sense. But if you look at it, Houdini is not just about CSS or writing better UI. It's more about its connection with JavaScript that makes extending and developing not just CSS, but the web a complete experience, and we'll get to it. First, let's travel back to 1994 when the W3C was formed. The more and more people were getting involved with the World Wide Web, and as they did, they started bringing in new ideas, suggestions, and feedback to improve the web. And within a year or two, JavaScript and CSS were released, and the web seemed to be growing at an extremely rapid pace. And with this feedback cycle in place, there was a need to keep the process stable. So the W3C was formed. And its job was to make sure that the web remains built on open standards. A lot of things happened in between 1995 to 2007. The DOM was introduced, AJAX came into play, and made possible the development of truly asynchronous client-side applications, and of course, propelled Web 2.0. So developers started innovating their own solutions for common problems, in the form of small tools and libraries, like the very famous jQuery library by John Resig. And then in 2010, Remy Sharp introduced the idea of polyfills. So the whole game was dramatically shifting, and backwards compatibility has been a huge deal for us. So keeping that in mind, developers started using and developing polyfills. But as the web grew further, there was sort of a feeling of dissatisfaction or some sort of a disconnect between among the community on how these web standard committees were, creating and prioritizing new features. So, and that's what led to the creation of the Extensible Web Manifesto in 2013. So, the Extensible Web Manifesto aims at creating this virtuous feedback cycle with developers having the ability to experiment and polyfill standards so that they can provide, some basic testable implementation and gain some insights out of it. And this movement was started by some of the most notable members from the community, including Brendan Naik, Yehuda Katz, Alex Russell, Brian Cardell, and many other people. And for the past couple of years, the community and the standard bodies have been working really hard on, working on hardened projects, providing early access to ECMAScript features, building transpilers, and in general giving developers the freedom to build new proposals and specifications. And obviously, in order to do this, developers need to understand the underlying magic or the underlying browser features. Because if you look at it, most of the web is high level, and it's extremely hard to polyfill or even test new features out. And that's the reason why the Extensible Web Manifesto also argues that the standard bodies should also expose and explain the underlying platform features or the low-level capabilities of the platform. And this obviously leads to quicker feedback by the community on new APIs and features, and quicker bug fixes, improvements, and overall streamlining of the entire standardization process. Now, taking this further, what if we were to polyfill a new ECMAScript feature? Can we do that? Of course we can, right? So how many people here have been using latest browser features since ES6 came out? Yeah, exactly. A lot of people. That's how flexible things have become. Instead of waiting for browser vendors to implement new features, developers themselves can innovate and experiment with latest features. But what if we were to polyfill maybe a new CSS layout or maybe a new fill type? Can we do that? Well, not really, because browsers don't really understand how to extend CSS. And we cannot simply define a new a display type or a new fill type, because all unknown values are discarded by the CSS engine, and that's the main problem. So where's all the underlying CSS magic? It's all hidden from us. Now, in order to fix this disconnect between the extensible web guidelines and the inability to extend CSS itself, the W3C have formed this sort of a joint task force, and this task force is codenamed Houdini, which is named after one of the most famous magicians of all time, Mr. Harry Houdini. And their aim is to expose the rendering engine internals to developers so that they can extend it and create better user experiences. So Houdini will help in explaining and exposing the magic of layout and styling done by the CSS engine. So we'll be able to hook into each of the processes in the rendering pipeline and be able to do all sorts of things, create custom layouts, define new paint types, fill types, whatever. So basically, extension of CSS via JavaScript will be possible, which is amazing. So the Houdini, I hope it's visible. So the Houdini working group has started working on these new drafts, which include a parser API, a paint API, a layout API, and few other APIs that expose the rendering engine internals. So let's cover them one by one. But before we begin, I should let you guys know that many of the things I'll be sharing are in very early stages. So the syntax might change, the APIs might change, So, but nonetheless, let's get started and see what Houdini has got to offer us. So first is the So first is the properties and values API. So this particular API extends the CSS variable spec, which obviously allows us to create custom variables. And it extends it and allows us to create custom typed properties. So like we can define a type in CSS now, so we can have typed CSS values. So this also provides us the ability to have, like I said, a type. We can specify initial values to our CSS variables, and we can define their inheritance behavior. So all CSS variables inherit by default. So this might come in handy where you want to disable this particular behavior. So let's see what the API looks like. So we have this register property function. And we're using it to define a new typed custom property called BG color, and I'm providing a type here which is of color, and with an initial value of black, and the inheritance parameters is optional, which is false by default. So having a type here is something new. So now we are talking about typed CSS values. So this obviously prevents invalid property value declarations. And so with a particular type defined, we always make sure that only a value of a required type is used with the custom property, otherwise it throws an error. By default, syntax, which is the type, can support any type of value. But with a type defined, such as in this case, where I'm defining a type of color, the initial value option becomes a requirement. So that's why I'm providing an initial value of black here. So let's look at a complete example. So we use the same BG color property of type color with the initial value of black. And we're using it to set the background color of the .thing class using the standard var function. So it's pretty simple, right? So overriding the default value is also pretty straightforward. So in this case, the background will be colored black since we have the initial value set to black. So you can simply override it by redeclaring your custom property. Now the background will be colored green. A thing to note here is that all registered custom properties are bound to the root scope. So overwriting a custom properties value like this will only have its effect on the current element scope, which is .thing. And so if you were to access the BG color property outside of .thing, it'll still give you the value black. What if a non-color value was applied to the custom property, like a string over here, which is not a color? Since we got this property registered with a type of color, and we have a default value set to it, which is black, the CSS engine picks it up and applies the background color of black to the class. So now this becomes extremely useful in cases where you would want to resort to certain fallback values for your custom properties. And of course, this prevents any inconsistencies in your UI, which is great. The syntax string supports the following types. We can have colors, we can have numbers, percentages, URLs, images, and a few other types. We can view the full list over here. Next up is the typed OM. So we've been talking about typed values over here. So this is what gives CSS the ability to create typed CSS values. So the typed CSS object model gives us the ability to convert value strings the CSS value strings into meaningful typed JavaScript representations. So we have a specific API for this, using which we can have typed representations of CSS values using JavaScript. So the type2m tells the rendering engine which particular types of values are to be manipulated. So this does not involve any sort of extra passing of value strings, as in the case of the old CSS OM. So this offers significant performance improvements. And it also provides us this new class called the CSS style value class. So and it also has a number of subclasses, which can be used for defining all sorts of type values. So we can have length values, we can have transform values, position, math, and few other types of values. It also exposes a style map. So style map is basically an interface which helps in setting and getting typed CSS values. So we can access the style map and use the set method if we want to set a new property value here. Like in this case, I'm setting the height property to 100 pixels, and we can use the same. We can use the get method to get the height back, which is returned as a subclass of the CSS style value class, which is the simple CSS simple length class. There's this open source typed OM polyfill available. I mean, you can play with it if you want to get a feel of how the typed OM is supposed to work. Again, this is a complete. This is just a proof of concept, so completely meant for experimentation only. I'll get to the browser support as well for all of the APIs, but that will come later. Let's talk about worklets. So worklets are kind of like the pieces in the puzzle that allow us to hook into each of the processes in the rendering pipeline and extend those processes to apply our own custom CSS. So this is where the fun part begins. Roughly, this is what it looks like. So we have different processes in the CSS engine, and we have different worklets attached to it. So for each of these worklets are invoked at various points in the rendering pipeline. So we can see we have a separate worklet for the paint stage, and we have a separate worklet for a layout stage, and so on. So we can call these as worker scripts for the Houdini APIs. So whenever they are called, they are called for extending on any of the processes of the rendering engine. And worklets are meant to be thread agnostic, so which means that they're not intended to run on a particular thread. So the rendering engine can choose to run them wherever it wants, which can be a separate worklet thread. And worklets, they run in sync with the rendering engine, but they are completely independent of the main thread. So that's the best part. So your main application code isn't affected by their operation. So this is how you would register a worklet using the add module method. So in this case, we're hooking into the paint stage. And when defining the worklet, we give it a name and a JavaScript class. Now, this is where all the magic happens inside this JavaScript class. Now let's see how this magic actually works with the paint stage of the rendering pipeline. So this is what the paint stage does. It's responsible for painting the background, the content, and highlight our box based on its size and complete style. So during this stage, the Paint API will allow us to create custom fills for our elements in the form of an image, which we can use using the background image property, something like this. So here we are applying a custom fill called myPaint using the paint function provided by the API. So first things first, we need to hook into the paint stage of the rendering pipeline, right? So what do we need for that? A worklet, right? So we'll define our paint worklet. This example is actually taken from the official Google developers website. So they're planning to ship the Houdini Paint API with Chrome 65, I guess. Someday next week is the release date. So we can see that we have a paint worklet called checkerboard.js, and we're using it to paint this div. So we have attached the checkerboard paint to its background image property. And this is the worklet code. So, so we have the register paint function, which we're using to paint our div. So this is like a standard function used in the paint worklet. So we get access to these 3 arguments in the paint function, which is basically the context. The geom basically is the geometry of the element, which returns the height and width of the element. And the properties basically are the style map properties we want to access inside our worklet. And using this paint function, we create the checkerboard with the 3 colors defined, so which are red, green, and blue. If you have some experience with Canvas, then this code might look familiar. Here also we're using the context variable to create and apply the fill. So it's quite the same. This is what the output looks like. It's a checkerboard fill made up of the specified colors. I know it's a very simple example, but it still tries to demonstrate how easy it is to extend the paint paint process in the rendering pipeline. And do note that the paint worklet will be called every time a screen resize operation happens. So the pattern is redrawn on demand and is kept intact for all sorts of displays. And this is completely normal because every time a fill happens, it's calculated based on the element's current size, which is generated during the layout stage. Additionally, we can use custom properties in our paint worklet. This is where the properties arguments comes in. And the properties arguments actually returns the style map. So we use the type2m here to get the custom properties from inside our worklet. As of now in Chrome, these properties are mostly, the style map is mostly a wrapper around strings, so that's why we need to convert it into a string over here. But going forward, it'll change as soon as we have stable support for type2m. The input property static function is required to fetch the required custom properties or any other properties that we need to use in the worklet. Now, the paint worklet can be used in many ways. So these are 2 simple examples: multiple colored border backgrounds, the material design, ripple effect. So the obvious benefit here is that using a paint worklet, this sort of effects becomes pretty simple to make. So you don't need to, inject extra DOM nodes here in this case, and it's pretty simple to use it. You can view the full list of examples over here. And obviously, you can use it to polyfill any of the proposed fill types that the browser currently does not support. Next up is the layout API. So the layout API gives us the layout worklet, which we can hook into the rendering pipeline to create our own display types. So first, let's understand what the layout stage does. So it's responsible for generating generating and positioning fragments from the box tree. So like a lot of weird words here. So let's see what each of these mean. So the box tree shows how the document structure looks like and what sort of elements are there in the structure. And this structure, and this is the structure that the API operates upon and lets us arrange all the elements together. And each of these elements can have multiple fragments. So as we can see here, so fragments are like the tiniest bits in the whole box tree. And they're also created for each of the pseudo elements. So like here in this case, we have a fragment for the first letter pseudo element, the first line pseudo element, which is highlighted by the black outline. Now, the layout API gives us the ability to create our own display types with respect to this particular box structure. This is what the broader picture looks like. We have the parent element. The current element is the element where we are applying our layout on. And then we have the child elements, which further contain our child fragments. So the access to the child elements is important here, because obviously we need to arrange the elements and the fragments within them to generate a custom layout. So let's look at the worklet now. This is what the class looks like. So we have a few static functions. Input properties helps fetching the property values of the current element, like we saw in the paint worklet example. Children input properties gives the property values of the child elements, and the child display static function lets us define how the children elements are to be displayed, whether they are to be inline, blockified, or whatever. Then we have two generator functions. The first one is intrinsic sizes, and the second one is layout. The intrinsic sizes function allows us to figure out what the max or min size of a block is, so that we place our elements accordingly and don't waste any space available, because there's a specified amount of space available for us to do our layouts within the parent. And the layout method actually defines how the elements are to be arranged by a custom layout. So we create a constraint space here, which is basically the space available for us to do our layout, and which is within the parent. And we position our fragments and resolve the block sizes to finish up the arrangement of the blocks. So this particular example is also taken from the official docs. So the example here aims at stacking all the elements on top of each other, which are inside the parent. You can't really play with it at the moment. It's a pretty vague API. None of the browsers have got it implemented. But it seems extremely promising. I mean, imagine writing a performant masonry layout without any JavaScript hacks. It's going to be awesome, right? Now let's talk about the animation worklet. So the animation worklet allows us to create highly performant scroll or input-based animations. Things like sticky headers, parallax effects, and all that. And all of this is done off of the main thread. So because we're using a worklet here, so this offers us significant performance improvements. So no more janky UIs with those scroll effects, I guess. And animations running inside the worklet, the animation worklet also expose the animation interface from the Web Animations API, which means we can, the worklet data can be accessed on the main thread using any of the Web Animations APIs. Now let's look at an example of a scroll-based Twitter header. This is the structure of the document. We have a header element and an avatar element. So we'll animate these two elements based on the scroll position. So as we scroll down, the avatar element will animate and get fixed to the top, and the header element will lose its transparency. So it also includes our worklet module inclusion code. Now, as you can see here, this is a promise. And inside the promise, we attach the keyframe effects. So these keyframe effects are provided by the Web Animations API, and we attach these to each of the elements that we want to animate. So in this case, we're passing an array of effects attached with each element. So we want to the avatar element to scale down and the header element to lose its transparency. And all of these effects will be available in our worklet code, which we'll see. We also create a new a scroll timeline on the scrolling container, which is the parent container, which listens for the scroll events, and it has an end and start offset set. So this is the worklet class, which contains a constructor where we define our easing function. Then we have a clamp utility used within the animate process. The animate process is basically the process which gives us the current time, which is the current scroll position in the document. And it also gives us this group of effects that are to be applied on the specified elements. So we set the scroll position on the which is the current time in the scroll timeline, and we adjust the time of the effects passed to us that gives us the ability to control the timeline of our keyframes. So this is how it would look. We can see that as we scroll, the targeted elements are being animated as expected. The best part is all of this happens off of our main thread. So this can provide us some really high performance benefits, like I said. Especially things with things such as parallax effects. This is a demo created by Sarma. So the Chrome team has put together a small polyfill for the animation worklet, and this polyfill is being used by all of the examples listed on their repository. You can view the entire code and samples over here. So there are two more APIs left, which are kind of fuzzy at the moment. Even the specs available don't have too much information about them to cover. One is the parser API, and the other is the font metrics API. But we'll still look into it and see what each of these APIs can potentially offer us. So the first one is the parser API. And as the name suggests, it will allow us to parse CSS rules or rule sets into typed OM representations. So your string-based rules get converted into typed OM representations, and it will also have utilities to parse entire style sheets, rule sets, and all those things. It's still like in very, very early stages, so can't say much about it. The last one is the font metrics API. So this will provide basic font metrics or font-oriented information for our document content. So currently there are two methods specified in the spec. So there's this thing called measure element method, which basically takes in an element and returns a font metrics object. And we have a measure text method, which takes in a DOM string and a style map and returns a font metrics object. The font metrics object basically is supposed to store information regarding the width, height, the bounding box, baseline information, all that of the element. So this will allow us to measure our textual elements and their orientation, and allow us to do some really cool things like creating some interesting drop cap effects maybe. So this was more of a brief introduction to the Houdini APIs. Now, the main question is, can you use Houdini today? And most of you might have guessed it. The answer is no. But it's coming soon. So this is what the current situation looks like. The Chrome team is definitely pushing it hard to ship the new APIs. Currently, you can experiment with the properties and values API and the typed OM, which is available behind the experimental web features flag in Canary. So you can go to chrome.//flags and turn the flag on. As far as I know, I think it's available in Chrome, stable Chrome as well, again behind the same flag. A fully functional Paint API, like I said, is to be released with Chrome 65 sometime around next week. So that's a good sign. Clearly no signals to implement the font metrics API or the parser API by any of the vendors. Few other browsers also seem to be catching up. kind of. So we might see some of the APIs being implemented in few of the browsers. Not really sure about the timeline, but be sure to check out is Houdini ready at .com to keep yourselves updated with the status of the APIs. With that being said, I think Houdini is going to offer us lots of capabilities to truly extend rendering engines and come up with really amazing tools and patterns that will facilitate the development of truly rich web experiences. And I'm really looking forward to it. That's it from my side. Thank you.
Thank you so much. Hello. Is my mic working? Nope.
Thanks.
Okay. Thank you so much, everyone, for giving us a glimpse into the CSS future. And that was a very informative, and you covered everything. I wrote down 3 questions, and you just keep answering them as you go, so I got nothing. I'm sorry. Sorry to disappoint. However, I do have good news. It's food time. We're actually pretty on time, so you have a full hour for food. And you know how yesterday I said the Zoan swag was only yesterday? Turned out I lied. Well, not really. They just updated it. But there will still be the Zoan booth upstairs, the same at the community lounge, same place as yesterday. Today from 12 to 3 p.m. So see you back at 1 o'clock.
Wow.
I got it.
Yeah, there's stuff up there, huh?
Look at
Hello. Do we have a lot of Berliners in the room? Yeah? Okay, well, if you don't already have a Metro Pass, here's your lucky day. Because Michael over here has a Metro Pass that would be valid until March 20th that he cannot use, and he would like to give it to someone who has use for it. So if you want a free Metro Pass, Berlin Metro Pass, go get it from Michael. Yep, guy over there. Second announcement. Later today, we're going to have a speaker panel with, I don't have the list of people, but with Anna and Sarah, Dan, and I'm saying this from memory. Anyway, so we're taking questions from the audience. So if you go on the site slido.com, SLIDO.com, and event code JSConf, you will be able to submit questions, and they will be moderated and voted on. And so if you're asking good questions, they might get answered at the panel. So again, it's SLIDO.com and event code JSConf. So far in this conference, we have a lot of talks about cutting-edge technologies. We have talks about specs that aren't even in the web standards yet. And then we have speaker literally importing modules from the future. And this talk is no different. This time we have, we have a talk about Firefox Quantum. When Firefox Quantum came out 3 months ago, it was making headline left, right, and center. Today we have Jean-Yves Pierre from Mozilla talking about some behind-the-scenes stories of Firefox Quantum. So please join me in welcoming Jean-Yves.
Thank you. So, hello everybody. I'm really excited to be here and to talk about how browser makers are making browser fast, and I will use Firefox Quantum as an example of how browser vendors are modifying the browser to cope with the 21st century. Most of the things that I'm about to say is also valid for a lot of other browsers, but I'm taking the example of Firefox Quantum. So I'm Jean-Yves Perrier. I'm part of Developer Outreach at Mozilla, and I have a Twitter account. So the story starts a little bit with how a computer works. So at the core of the computer, there is a processor. And processors have evolved over the years very quickly. Initially, in the 70s, 80s, 90s of last century, there was something called the Moore law that was basically saying that every 2 years or every 3 years, your computer becomes twice as fast as previous, which was very convenient for people making programs and browser in particular, because you do nothing and 2 or 3 years later, your browser is twice as fast. It's kind of free lunch. Lately, at the beginning or second decade of this 21st century, people are seeing that processors are not really doubling the speed anymore each 2 or 3 years. It's still a little bit true for the high-end processors, but in fact, it doesn't really matter for the web, because we are no more in a point where we want the web to run only on the high-end processor. Most of the time, you want it to run on such device, and it's not the latest, the most powerful processor in it, because else the battery will just last 5 minutes. So processors has found a different way to increase their calculation power, and it's by having more cores, so more processing power in parallel. And the difference here is there is no free lunch. Program has to adapt themselves and to make use of these multiple cores, of this concurrency that is now available. At the same time, for browsers, what we want browsers to do has changed over the years. So at the beginning, it was just displaying a document, and even in 2005, if you were able to put a few images and making rounded corner or on the box, you were a top-notch developer. It's not the case anymore today. And what we want today is to have HD videos running with transparency effect, with rotations, and you want all this to run at 60 frames per second. You want all this to run on your virtual reality headset, which means that, in fact, you need more than 60 frames per second, because if you want, with a virtual reality headset, not to have motion sickness, you need at least 80, if not 100 frames per second in order to achieve this. In order to cope with this, browsers had to adapt. They were designed in the 80s, end of 80s, and mostly at the beginning of the 90s. Even if they have evolved over the years, it's not the same architecture that is able to run the modern web. So this story today is about telling you what browser vendors are doing in order to make your website, your web application faster, even without you having to do anything. The browser is a user agent, and in 2008, we used this robot for the launch of Firefox 3. It's a friendly robot. But of course, over the next decade, it looks a little bit clunky. Is it still the user agent that we want to have on the web? So the question is, what a modern browser is doing in 2018. Sorry. First part is, how does a web browser work, and especially the rendering engine? So this is quite important to understand a little bit so that you understand what the changes are happening. So the first thing is your browser is downloading pages. It requests handle on the web, and it gets HTML, the JavaScript, the CSS files, and just pass all this into an HTML parser, the JavaScript engine, the CSS parser. And what it does is to generate the DOM of nodes. So each time you modify the DOM of nodes, the whole process starts again, not the downloading, but what follow up. So with the CSS, the first things to go in a rendering engine is a style engine. The style engine take the CSS and apply and define what rules are applied to each of the boxes. It doesn't apply them yet, but it just defines what are the set of rules that match each element of the DOM. When you have this, you add all the media. So the images, the videos, and you can know the size of the images, the size of the videos. And when you have this, you have a phase that is a layout, which is in fact defining where on the page will be displayed each of the boxes. You have several layers because they can be on top of each other's, but you don't know yet what is inside the layers and which layer is winning. The next step is a paint. So this is to apply texture on each of the layers that will define, okay, this texture is the video, this texture is the image, this texture is just a background or some text. From this, then you have to define which pixels are visible. This is the next step and the last step. That is a compositor. And then you go to your page on the screen. And each time you modify the DOM, you have to go through this process again. For years and years, browsers have already optimized this part by only redesigning or redrawing the part of the page that are actually modified when you change the DOM and not the whole page. But this is really the big and important element. At Mozilla, in order to improve this, we wanted to test new algorithm, and we wanted especially to work on parallelization. So what we have done, first we have created a new language called Rust. Rust is replacing little by little the different part of Firefox written in C++ by this language, and this language has been designed to make the writing of codes that can be executed on multiple core, on multiple threads, much easier, with less errors than C++ and so on. That's really important because a lot of people are contributing to the code. And even if most people are really good programmers, they do error, but you can also get patches for programmers that less experienced, and they will not do the basics common errors. We created then an experimental engine, an experimental browser called Servo. It's written in Rust. It has algorithms that take parallelism and that allow us to check if these algorithms are working very well. And also, it has no significant UI. It's not a real browser. It's something to test if the ID we have are good or not. And finally, and this is the most important part, Servo can break the web. The web is a very complex piece, and there is a lot of special cases with special CSS properties and so on. And in fact, to test the algorithm, you don't want to have to write the engine in all the detail first. You want first to validate that in the good case, in the easy case, you get the speed improvements that you wanted to have. So we did this Servo, and we developed a lot of things on it. At the same time, we wanted to solve several other problems. So Firefox had a stability problem. We noticed over the last few years that it has a lot of crashes, and we were wondering why. It has an old theme, so like the robots that is just looking old, by just having an old theme, when the UI in OSs has been improved, it feels slow. And also, there was a lot of cases where, in fact, the user interface was freezing. It's called UI young. And finally, we wanted to have the new algorithm. So we launched a project called Quantum at the beginning of last year, and we decided we want to make a quantum leap in performance and in the way the websites are rendered. There are several things that has been done, but the first thing, and I want first to thank my colleague Lynn Clark, who has drawn this amazing drawing. I'm absolutely unable to make any drawings that looks readable by anybody. So she's doing a lot of these drawings. She's writing blog posts explaining how our browser is working. There will be a link later that allow you to have more information. So the first thing that we have decided to do is to change our style engine. So the style engine, as I said, takes the different CSS properties, look at the selectors, at the specification, and in fact, for each of the boxes, define, OK, these properties with this value apply to this one. For example, the background color, or the text color, the font, and so on. This is something that has to be done to each and every boxes. So this is, at first sight, something that can be used very easily with parallelization. And so we tried it in Rust on Stylo. So basically, we had several processes, several threads, that takes part of the tree and makes the calculation. And of course, it's not that easy because first, you don't have one thread, one process per element on the page because there are sometimes several thousand of them. So you have to give chunk of the page to each of the processes. So that means that some of these processes are just idle at some point because there is nothing happening. They have finished their work, while others may be extremely busy. So there is a very big, complex algorithm here that allows the different threads, the different processes to still work from the other when they are idle. So with this, we created and we validated that the new way of doing styling in the browser is, in fact, much, much more efficient. But that was only the first step, because this is in Servo, in the experimental browser. We needed to sort out all the detail and to integrate this into the real browser. And integrating a new style engine in a browser, it's a little bit like doing heart surgery, but with a person that is still conscious. You want the browser to continue to work. You don't want suddenly have no new release for 1 year, 2 years, while you put all the wire together. So we took the stylo, the quantum CSS, with a parallelism. We integrated with the rule tree from Firefox. And also we took the style sharing cache from Chrome and Safari. So the style sharing cache just memorize things you have already calculated, because sometimes on the page, a lot of nodes have the same ancestors and the same values, so it works pretty well. In fact, it wasn't working that well anymore, because lately, with all the pseudo classes and so on, it became more complex, and there are less of these elements that are there that were cached. So we modified the style sharing cache in order for it to work again. And then we just transplanted stylo into the browser. And this happened last November in Firefox 57, and we got, for this part, a very, very large improvement in speed. So stylo is the first technology transfer from Servo. It's not the first part of Rust inside the browser. And it is solving a problem that is called embarrassingly parallel problem. By definition, style engines are doing something that can be massively parallelized. And of course, when the page is simple, you see little improvement. When the page is very complex, you see a lot of improvement. Browser has another challenge. Each time you click somewhere on the browser, there is an event handler going on and firing and executing some code. And you want to be sure, if you want to have 60 frames per second or 120 frames per second, that all that's happening on the main thread, and especially these handlers happening, is no more than 16 milliseconds, or 8 milliseconds for 120 frames per second. So that means that you have to go out of the main thread as soon as possible, because while you are in the main thread, you cannot handle the next event. So next event when you are scrolling a page or when you are clicking and so on. Initially, browser had everything on the main thread. And little by little over the years, they start to take things out. So first of them is the video decoding that is happening now most of the time on the graphic card itself. There was the plugins also at this place, Canvas Worker and several others. But what is quite interesting is we have another piece of computer power on the browser. That is a GPU. Oops. The GPU is designed for games, is designed for the operating system, where you have a lot of calculation to do on a lot of data. The same operation on a very large amount of data. And it's very, very efficient for this kind of things. It's very efficient for gaming. On the browser, we have this kind of operation. One of them is the compositing. So the last bit of the calculation, where you have all the layers and you have to define which one are visible or not. It's the same operation most of the time on a lot of data. So we decided in 2016 to offload the composition to the GPU, and we did it, and it improved a lot. At the same time, a little bit later, in fact, we noticed that the crashes just increased. We had a lot of crashes. And in fact, it wasn't the browser itself that was buggy, it was the drivers that were buggy. So the crashes were mostly happening on Windows, and for example, Mac has very few crashes because there are far less type of driver, far less types of graphic cards, and less bugs. So we decided last year to solve the crashes by having the GPU, the graphic drivers loaded in a different process. So the process crash, the browser detects its crash, it restarts it, and then it works without using the GPU for this part. So you don't have all the speed improvement of the GPU, but you don't have the crashes either. So that's a way we had to mitigate the bugs in graphic drivers. So the compositor is the first part that went to the GPU at the beginning of last year. Another part is a painting. So the painting is to take a texture and to apply it to a surface. It's called rasterization. And we want to do the same, offloading it to GPU. And this is a project called WebRunner. It's not yet finished, it's in progress. This is the ultimate goal. I don't know when it will be finished, because if you ask the management, they say very soon, and if you ask the developers, they say, oh, in several years. So it's somewhere in between. Meanwhile, we decided that, okay, even if we don't send it to the GPU, we can remove it from the main thread. So we have what we call off-main thread painting, just a thread for the painting. And this has been done in Firefox 58, which went out in January. So basically, we create a set of instructions, the display list, that is applied to, assigned to the layers, and then we send it to another process that's rasterized, which is the actual painting operation, and then sent to the compositor that is in its own process or on the GPU. And that way, as soon as the rasterization is no more on the main thread, so that means that you can create the next display list and so on. So we remove the bottleneck. It's not as perfect as having everything on the GPU. We still sometimes lose frames when it's go a lot of changes, but much less often. It's no more the rasterization the problem. So this landed in Firefox 58, and there is an improvement coming, the next version in 2 weeks, where in fact we discovered that the display list, we don't need to recalculate it each time. It was simple, but it's not the most efficient. So now we have heuristic in place so that we don't recalculate the display list or the whole of the display list each time. So until now, we have mostly seen replacement of pieces of the browser. And in fact, if you want to have a browser that is efficient, that feels quick, responsive, you need to consider it as a system as a whole. Because yes, you can have a very efficient style engine, but maybe the bottleneck is somewhere else. So we changed the way to do development and to prioritize the development at Mozilla by having the motto measure all the things. Then we triage, we prioritize, and we remeasure. And we applied this, and we still apply this to fight Yang, so freeze in the UI. And there is a collection of 30 blog posts by Eshen Aghari that explain all the changes that happen all over the place. It's going a lot of details. And he coins the name death by a million cuts. We found bugs where we had to fix 10 bugs, and suddenly we get back a lot of time. Each of the bugs individually in the individual fix were just shaving 1 millisecond here or there, but no significant difference. But the 10 together were giving a lot of differences. So one of the things that we changed is the way we were doing scrolling. It's not specific to Firefox at all, and it has been pioneered by Apple, and it's called checkerboarding. When you scroll on your screen with a mouse or with the finger, you never want the scroll to stop. But sometimes it goes too quick, and you don't have the time to calculate what to present to the screen. So you present a default value, and people, instead of being confused, scroll less quickly. The data appear, the images appear. And initially, it was a checkerboard. That's why it's called checkerboarding. So the overall speed is not better, but the feeling is completely different. Another big thing that we have changed is what we call IPC, inter-process communication. So it's known for a long time that when you communicate, for example, with a disk, it takes a lot of time, and you don't want to do this on the on the main thread. It's the same when you communicate with another process, especially if it's synchronous communication. You don't want to do this on the main thread. So we fight synchronous communication, and we wanted to have as many asynchronous communication at all. And this is where we did a lot of measure and so on. There was, for example, 2 people working for 6 months on the cookies, because cookies where needed a lot of synchronous communication. They rewrote completely the cookie mechanism in Firefox. And in fact, it was 25% of our blocking on inter-process communication. And on big website, when it was fixed, like Facebook is making several write several times per second to the cookie store. In this website like Twitter or Facebook, we were able to win in the order of the second in the time we made to display the page. There was other offenders like plugins, but plugins are gone today, or the traditional extension on Firefox, the Zool extension also were an offender there. So we had to decide to stop having that. There are plenty of other things that we have done. For example, we have changed some algorithm. They are still efficient, but they were already efficient, but in fact, sometimes they were not making good use of the cache. So we keep an algorithm with the same complexity, but that works better with a cache, for example, and suddenly you have an improvement of your performance on complex pages with the same complexity of the algorithm. Also, the garbage collection, so the parts that take back the memory, has been changed. Instead of having to do a complete sweep, or we can now do an incremental sweep. So we take a bit of the memory, we stop because we have only a few milliseconds, and then we continue later. So that means that the memory grows a little bit, but when the browser is idle, it goes back to normal. At the same time, we notice that memory that is used towards the end very quickly and so on is the one that usually is released very quickly, and what you have done, I don't know, 2 hours before, usually you will keep it until you close the browser. So we also have changed these kind of things. And the last thing is we try to remove all timers in the interface. Timers are really, really bad. At first look, it looks very nice because you delay the execution later. But in fact, you don't control when the execution will happen. And when the timer will fire, not only it will fire on the main thread, but maybe it's a moment that is important for something else. You have no control. So in fact, the web platform, and this can be used also on website, we have now request idle callbacks. Let's say fire this or do this when the main thread is free. We also did things like throttling background tabs. So if it is in the back, it's less important. But of course, if there are music playing in the back, you don't want your music to stop. So we are very, very defensive here, and we process with experimentation. And finally, we redesign our user interface. So the feeling of the user interface is something really important. So the look has to look modern, and it doesn't change the speed. It changes the perception of the speed. One thing we change is every animation now is happening on the GPU. It's happening through CSS. We had in the previous interface still animation done in JavaScript, and they were causing a good deal of the yank. So that's really important that animation not in JavaScript on the main thread. We change a bit the structure of the user interface, so it's quicker for the user to find elements. It's not quicker in speed proper, but it's quicker for the user. So with all these things together, we have now a new engine. And it looks still a user agent, still a nice robot, but it looks much more modern. And it's not finished, in fact. Quantum was released in November, but already the two next versions of the browser had more improvements. The web render is coming soon, or at some point. We have other ideas to improve things. And in general, browsers are still evolving. It's not the end. It's a new beginning because it's the first time we have now this power of having a massive parallelism on a browser. So I want to thank you to here. Also, you can help by installing Firefox nightly, by reporting problems, especially when your application or your website is much slower in Firefox than in another browser. This interests us because it's difficult to have real-life data. Each time we do a commit, there are 2,000 hours of tests going on a farm of computers. But it's tests. It's not real-life things. So if you file a bug, say you can give help by reproducing it, engineer will be very happy. Spread the word. We want as many people to use as many browsers as possible, Firefox if possible too, because competition is good. That's a way we improve speed. And Firefox Nightly Twitter account is where to stay informed. Thank you.
Thank you so much, Jean-Yves. Yeah, that was very interesting. I have so many questions. Should we start with the easy ones? How are you?
I'm fine.
So you mentioned the composition being offloaded to GPU, but then not the benefit is not universal because the Windows machine seems to crash a lot more because there are more different drivers. And you also mentioned composition being, no, painting wanted to be moved to GPU as well. Will it also suffer from the same?
Yes.
Yes, okay. Can I then derive from that and say Firefox Quantum runs better on Mac than Windows machine?
No. It's a bit more complex than this. So Mac is an ecosystem that is a little bit easier because there are less drivers. But the hope and the reality is that drivers are getting better and better because we file bugs to the driver vendors. Yes, all machines, especially for painting, all machines will never have web render working. But little by little, this problem will go away.
Cool. Thank you so much. A round of applause,
Thank you.
please. So I didn't have the list of speakers for the panel, but I do have now. It's going to be Sarah Drasner, Sean Larkin, Anna Henningsen, and Dan Abramov at the panel later. So if you have questions that want them to be want answers to, please go to slido.com with the event code JSConf and enter your question. We'll be back in 8 minutes. Hello, hello. What was that? Next up, we have Madlina Kluner, hailing from Zurich, Switzerland. She is passionate for design and storytelling with the newest technology. She believes in bringing people from different backgrounds together to solve problems in creative ways. And Madlina, sorry, my bad, is here to talk about 3D ray tracer with JavaScript. Enjoy.
Thank you, Vanessa. Hello, everyone. It's really packed in here. Thank you all for coming. As Vanessa already said, my name is Madlina. I am from Switzerland, and I'm a game designer and currently a full-stack developer at Archelogic. We are working on a toolkit in JavaScript to provide 3D models for interior spaces and also APIs for spatial analytics. So what we do is we want to make 3D models accessible for every web developer that would like to integrate this in his daily work. As I studied game design, I'm really excited about games, as you might see there. I love to play games, I love to collect retro games, and I also love to make games, which usually includes working in 3D. I also really love traveling, as I see it as a resource for a lot of inspiration, especially for storytelling and finding new ways of designing. And I also love creative things and music and a lot of other things, especially Iceland. I've been here 2 times already for a long period of time. I have not seen anything. So, you definitely have to come back. Why should you, as a web developer or JavaScript developer, be interested in doing 3D on the web? As we might already know, most of you guys, folks, as might everybody know that WebVR is coming. And 3D on the web is very accessible at the moment. And we're also challenging browsers, like Jean-Yves was explaining before, to actually support 3D on the web. There's lots of things you can do to enhance your product. For example, this is a screenshot from what we are doing. We are having semantic 3D models, which we can then analyze with machine learning for spatial data. And we can actually also use machine learning to propose you how you should furnish your apartment, which is pretty cool. So you can see your new house already before it's actually being built. Or you can make really cool small games on your browser, on your website, integrated it with all the native web environment things that you have, and you can make them work with each other, which is really cool. You can also use it to enhance your infographics or to make your data more readable with enhancing it with the 3rd dimension. So you can also use animation, time, and the 3rd dimension to show something you would like to do with your data. I think this is pretty interesting, and you should definitely think about how to use it. Most developers that would like to start with especially WebVR have been coming to me and asked me, how do I get started with 3D? Why is it that it's so hard to get started for these people? And this is what I would like to talk to you about today. I would really love that you come out of this talk and you have this little toolbox with things you have heard before and you feel more motivated to start trying it. Because at first, you will be overwhelmed by all the new terminologies you're going to encounter. Not only have you have new things to learn, but you're also going to be a movie screen designer. You're going to be a narrator. You're going to have to learn how to do UX in 3D. You're going to have to learn about 3D modeling, how to light a scene properly, etc., etc. That's a lot of things to learn. I would like to talk to you first about the physics of light. So here you see a very simple scene. We have this little apartment. Yeah, it works, okay. And we see a computer standing on a desk, we have a chair, we have a window, and outside we have the sun, which is primarily the source of light, which makes us see everything. But how does that actually work? So every light source, for now we're talking about the sun, is emitting rays of electromagnetic waves. As soon as these rays are hitting an object, they are going to interact with that object. So either the object is absorbing all the light, in that case a lot of energy is being produced, or parts of the ray of the sun are going to be bouncing off and reflecting on different surfaces until that light energy is used up. So I already said that. The electromagnetic waves consistent of different frequencies, so that means different frequencies are different colors. If one frequency is absorbed, the other two frequencies are going to hit our eye, the retina of our eye, therefore creating this color in our eyes, and we can see it. Different materials react very differently, which I'm going to talk about the differences afterwards. But there is three major things, as I said already. It's absorption, reflection, and transmission of light. We can see this here a little bit more graphically. Imagine you have a perfect mirror, which is it's not possible, even if you polish your surface very well, you're never going to have it, but theoretically, a perfect mirror will reflect all the light rays uniformly. This we call specular reflection. Then we have diffuse material like cloth and like wood and other things that are not so much reflective. So it's gonna take the rays and bounce them back in a very chaotic way. And you have propagated light. So if you have glass or water, the light is not only going to reflect, it's also going to transmit through the solid, creating these really cool effects. So this is of course not everything that defines a material, but as we can see in this illustration, these three components make a lot of our real life materials. And it's never just one component that is there in one material. For example, if you imagine you have a wooden floor that is not polished, the rays of light are going to bounce back chaotically. But if you then put a polish or a finish on, it's going to be very shiny from specific angles. And that's what I really want you to think about when you get started with 3D, because that's what a lot of people get wrong. Or just don't think about, because why would you? So how do we now translate this into computer graphics? I would like to just go back to a few centuries back, where the first cameras were appearing, and these are called pinhole cameras. So you have a light-sensitive film on the back of a box with a little hole inside. And only one ray of light per angle is allowed to pass through that hole, creating then the color on that spot of the film. And we are also using this technique in the render engine technique called ray tracing, and that's what I'm going to talk about. However, if you imagine again the sun, it's not only shooting one ray at a time. It's like a really, really big energy source, and it's shooting down all these billions and billions of rays at the same time. And most of these rays are never going to hit our eye. They're never going to hit our camera or whatever specific spot that we want to look at. So what computer graphics are doing is they use a technique called backwards ray tracing. So we are tracing the rays, but instead of going from the light source, we're going from our camera through the pixel that we want to trace, and we shoot a ray into the scene, and we look at the first object that we're going to hit, at the closest one. From there, we want to see if this one object is in shadow or if it is in light. Okay, so if the object is actually lit, we're going to use the color of the material that is defined at that space, basically multiplying it, simplified set, multiplying it with the color of the light, the intensity of the light. If the object is in shadow, we're just going to use black for now as for shadow. This is very simplified. But now, I also talked about these other things that are called like transmission and reflection. So how are we handling this in ray tracing? Imagine we want to see where, if we have a transparent material like glass, we would like to see what can we see through that glass and what is reflected on the surface of that glass. So on the impact point, we have to calculate the different rays that we're going to trace. One of those rays is going to be the reflection ray, and one of them is going to be the refraction ray. It's a bit, not very nice that the names are so close. And from there, from these rays, we're going to do another check if they are hitting a next object. So if the reflection ray is hitting this red sphere, it's going to be red at that point, but the refraction ray is hitting this green sphere, and so we have to calculate together if we want to have the pixel there red or green. From the impact point of the secondary rays, we're going to trace towards the sun and see if these points are in light or not. I want you to have a moment to look at this code. Did everybody get it? Can you come here and explain it to me? Because this is how I feel about my own code after 2 weeks of not looking at it. So what you're looking at is a basic implementation of a ray tracing engine that can do reflection and refraction with geometry primitives of spheres. And I'm not sure if planes as well. I think only spheres. And this is a common challenge among people who do computer graphics, is how to make the most compact ray tracing engine that can be fit on a business card. So this actually compiles, and I think that's pretty cool. But let's take it apart a little bit. So what we want to do is we want to define our geometry primitives. And for now, we are just going to talk about a sphere, because a sphere is one of the most easy shapes to calculate intersection. And for that, we need a center and a radius, and we want to have the material, because as I explained before, that's the most interesting part. And we're going to make an algorithm that will calculate our intersection from that. If we are successful, we're going to return both points that are intersecting with the sphere, because usually you will have two of them. So the distance to the closest one and the distance to the further away one. Then we're going to start our main function, and we're going to define the geometries. And again, for simplification, our light source are also going to be spheres, just with a different material that actually emits light. For that, we can test afterwards. We're going to have a buffer for our canvas, and we're going to go and traverse through each pixel. And we're going to trace for each pixel one ray. That's what we did before, right? Then in the trace function, we want to see again, this is the primary ray that we talked about before. And we want to see which is the closest object. So we're going to test the ray against every object in the scene. And as a result, we get the nearest one back. if we don't have one hit at all, we could just return a background color because there is nothing there. And there will never be something there. That's the really cool thing about ray tracing. You actually test against the whole scene. If there is an object there and it's a transparent or a reflective material, we're going to have to shoot the secondary rays for each of those. And we do this recursively until we are satisfied. And usually you don't want to do this endlessly because it's going to take forever. So we're going to decide how often you want to do this recursion. And at the end of that, you will test against the lights and see if these points are in shadow or not. Then you're going to use a Fresnel algorithm to see how you should calculate the lights together, or the results of the colors you're getting. I'm not going to explain that right now, but it's very interesting to look at. And if it doesn't fall into this, that means we are hitting a light source or a diffuse material that is not going to reflect any different points, so we can break the recursion there. I did not make another slide for this because I think it's clear. And this is the result that we are getting from this. And I think it's very interesting to see that from this rather simple algorithm, we already get really cool effects. Like we can really see the spheres that are close to each other reflecting each other. We can see shadows, and we can also see what's behind the camera, which is pretty cool. And this is something that you do not generally see in games, for example, or in different render engines. And why is that? We're going to get to that later on. So this was really easy, I think. But now we want to really go realistic, because we said before, there's not one ray per pixel. Usually the sun shoots so many rays that make up 1 pixel of your image. There is so many things that come together. We want to have soft shadows. We want to use multiple light sources. How are we going to compute these together? How are we going to decide on what is more weighted, which pixel should be what? And we really want to have this physical correctness, which means that we have to basically bounce the ray forever until it hits the light source by itself. Right now, we're just making it a shortcut because we just test if it will be hitting the light or not, if there is something in between or not. This is going to use a lot of computational power. Ray tracing is a really old technique. It's from 1984 was the first SIGGRAPH conference that was taking this as a topic. And since then, we're still not there where we have real-time ray-traced engines that are working. It has a lot to do with this, that you cannot make shortcuts to make it look good. You have to have a certain amount of samples, unless you're going to have a really, otherwise you're going to have a really noisy scenery. Yay! So we have a lot of new light sources in the room that are also casting rays. I would like to just very briefly introduce to you rasterization technique. This is the most common real-time render engine technique that is being used. And it's just as ray tracing, it's just as fundamental, this technique. It has been around almost the same time, because when ray tracing was introduced, the computational power was not good enough or not strong enough. It would have taken them forever to render 1 frame of an animated movie, for example. So what's interesting about rasterization is that it's also trying to solve the visibility problem. It's also trying to find out which object is laying in shadow, or what's the color of it. But it's doing it in a very opposite way of ray tracing. While ray tracing is going from the eye or from the camera into the scene, rasterization is going from the objects or from the scenery onto the screen due to perspective projection. So we take all the numbers and all our points and all our vertices, everything, and we project it onto the screen. For this, it's currently using triangles, which is also a rendering primitive. The cool thing about triangles is you cannot subdivide it anymore. It's already, you cannot make more areas out of it. And the areas is always planar, so we never have like a perspective warp or something, which makes it really cool to then project and test. What we then do with the triangles that are mapped onto screen space is something that also Jean-Yves has been talking about before. We are rasterizing each pixel for each triangle that is visible, and we map their Z-value, so how far it is away from the camera, so that afterwards, when we color it in, we know what's on top of each other. And if we have transparency, then we have to consider the Z buffer, because that's how we're going to put it together. Which also tells us that the Z buffer is basically, so a transparent object is basically just a look-through with a different alpha value, which does not have this refraction rays that are kind of warped around in the scene. So here in this image you can see two basic implementations. One basic implementation of rasterization and a basic implementation of ray tracing. And you can already see the difference, I think. While rasterization has come a really long way, if you have played any 3D games recently, or if you are working with WebVR, you're going to know that it's not going to look like the image up there. So there is a lot of simulations of real physics happening in rasterization. But generally, this implementation is also really a lot of work to do to simulate these physics. But they are doing a pretty good job. The only problem is still transparency, I think. So just a quick overview of the two. Ray tracing is mostly physically correct if you put enough effort in it. It has very high details, very nice side effects that you don't have to think about. You get the soft shadows, you get the reflections, you get the caustics. But it's very computationally heavy. So we are going to use a lot of computation time to render frames. And if we ever want to do this real time, we're going to either have to break it down or we have to make cuts. And rasterization is super fast. It's really only one transformation, basically, from your world coordinates to your screen space coordinates. There's a lot of tooling and hardware support, so your GPU in your computer is designed to do rasterization. It's not designed to do ray tracing. And most of the, like Pixar and most of the rendering people I know, they're still rendering ray tracing with CPUs, because it doesn't matter to them if they are 3 times faster or not. What matters is that they have to change all their tools, and they have to change their engines to be supportive of GPUs for just a little benefit. So you have the physics that are not really correct. You have like an approximation of what you can do. And you have quality loss due to that. So this is kind of the point where I hope you are all, oh God, how should I even get started? It seems very complicated. So I would like to introduce to you A-Frame toolkit. And A-Frame is a web toolkit where you can really easily get started with making your own 3D scenes. And if you're a fan of HTML, you're going to be really happy, because this is what it's going to look like. So you can define, with HTML tags, you basically define everything. You define your scene, you define the sky, you can put sources in if you want to use a sky texture. If you prefer to use a sky color, then you can put a color. Then you have this geometry primitives, as you have usually, boxes, spheres, cubes, whatever. Planes are also very prominent. And you can also define the lights. And that's where we come back to the beginning. Because with these components, you're gonna make or break your scene. If your lighting is good, you can really achieve a lot by just having 3 or 4 or 5 different objects in the scene. And the best part of A-Frame is that it comes with WebVR integration. So you don't have to do anything. You can just lean back, you import your Vive controls, or every major headset is supported. Also, mostly every major headset controller is supported. So this is what that example would look like for onesie.js. But that did not look very good. I mean, the background does, but the foreground. So it's still the big question in the room is, how do I get my 3D models? And that's where also we come in. So for example, this is going to be in your head of your HTML. You load all these external components. They're called A-Frame components. And I think the open source community is really doing an amazing job here, because you have all these really cool components like A-Frame orbit controls. You have people that are building environment presets for you. So you can just import them and say, I would like to use this preset. And then afterwards you can always use animation of each attribute to change your scene the way you want. And you can, if you don't like HTML, you can do that with JavaScript. So you can just edit your HTML attributes programmatically to make them animate. And this is how you're going to use the A-Frame components that are made by external parties. For example, you can load a 3D.io furniture of your choice. You can position it, because position attributes are just generally used for each object. And you can have your camera rotating around that object, and you had this really nice background that you love so much, and you just want to lay in that bed, and with the VR headset, yeah. So this, I think, is really cool, and you should definitely try it out, because there is so many amazing things that people are doing with this. I would like to share with you like a few tips and tricks. This would just be a talk on its own, but this is what I have been asked most of the times. Again, how do I get my 3D content? Should I go now and start to learn Blender? Because that's a pretty frustrating tool to learn. I know it. I've worked a lot with Blender, but it's pretty powerful. However, you don't have to do that, because some people, like my coworker Thomas, are writing inspector plugin for A-Frame. So A-Frame has a 3D inspector where you can manipulate your scene, drag around things, try out your values that you then can port into your HTML file. And you can use this inspector plugin to get models from, for example, Google Blocks. And just try it out, scale the models, have fun with it. Then lightning. Not lightning. Why do I always say lightning? Lighting is going to make or break your scene. So I think it makes a really big difference. And if you're interested in this, I have high motivations to write blog posts about this topic. And then for the end is content optimization. We are people that work mostly with the web and with different devices. So if you start working with 3D for a project, think about what is your target group. If you want to use 3D on different devices at the same time, keep in mind that you might want to design it differently for whatever you want to do. If you want to do a fast-paced game, then you have to maybe not be so detailed. But if you want to do product, like you want to have a 3D scene of your product that you try to sell, you might want to be more detailed on that. So you should be thinking about loading your assets progressively. That means you could have your textures in different sizes or different formats depending on what your device is capable of doing. And you should design for level of detail. If there's an object in your scene that you're only going to see 2 pixels, don't make it have 1 million polygons, please. And these are all the lessons that we have for free from game development. Also, one other lesson that we are actually doing, or that I was working on, is we do use ray tracing for calculating light simulation for static scenery. So the parts of our scenes that are static, we use a ray tracing engine to calculate in the cloud what is our realistic light, and then we put it back into the rasterization with the real-time stuff. So this is also really cool workarounds. So 2 takeaways, and then I'm done. Models, materials, and lights do matter. And this one is mostly for myself. I love ray tracing, it's really cool, but are we ever going to have it real time? NVIDIA is having really cool demos on this, but it's still a question that is unanswered. Thank you very much for listening. If there's any questions, please ask me anytime. And this is to get you started. So Scratch a Pixel is amazing resources for any computer graphics pioneers that would like to get started and really try the engine out themselves. A-Frame is the tool that I have been showing you if you just want to play around. And 3D.io is what we are working with to provide you with the models you need. Thanks.
Thank you so much, Lina. So it's break time. We have 38 minutes from now. Everyone has to leave here because we're taking down that wall and switching back to one main hall. So come back at 2:50, please. And ask questions on slido.com if you have not already done so. You did very well.
try to do it quietly. Not a whisper, more like a shock. I try to disorganize neatly what to keep and what to block. I shout like that old fly. In the window and wait.
Wrote you this, I hope you got it safe. It's been so long, I don't know what to say.
Hej, hej. 1, 2, 1, 2, hej, hej. Nei, okkur gerst þetta, heyrðu þið? Já, ok. Hej, hej. 1, 2, 1, 2, hej, hej. 1, 2, 1, 2, hej, hej. Hej, hej. 1, 2. 1, 2, 1, 2, hej, hej. Hej, hej. 1, 2, 1, 2, hej, hej. Hej. 1, 2, 1, 2, hej, hej. Hej, hej. 1, 2, 1, 2.
We had some keynotes last time which were not technical. Hello.
Hello.
It's hard letting go. I'm finally at peace, but it feels wrong. Slow, I'm getting up. My hands and feet are weaker than before. And you are folded on the bed where I rest my head. There's nothing I can see. Darkness becomes me, but I'm already there. I'm already there. Wherever there is you, I will be there too. There's nothing that I take back, but it's hard to say. There's nothing I regret, 'cause when I sing you shout, I breathe out loud, you bleed, we crawl like animals. But when it's over, I'm still awake. A thousand silhouettes dancing on my chest. No matter where I sleep, you are haunting me. But I'm already
I don't want to wear this. I don't want to wear it. Shall we? Hello.
Hi.
Did you miss this duel?
We missed each other. We're finally back together.
Aww.
Yeah, it was sad not having you on the other track, and I can't watch any of the talks.
I know, and
on
that
this
wall
track.
was so soundproof. I couldn't
Yeah,
hear.
I know. I thought I could like yell across and be like, Vanessa,
Also,
are we on sync?
I heard there was like a concert going on, right?
Yeah, did you hear?
No, we heard nothing. It was
No,
just
he
quiet.
was, like, playing like awesome guitars. He was just like doing the solo, being like, yeah. Yeah, that was awesome. I love that. It's too bad you missed it because you weren't the other one. It was honestly the best track.
I hate you.
Oh man. Awesome.
In case you have not heard yet, we have you can ask questions on for the speaker panel later, and you can post your question on slido.com, slido.com, with the event code JSConf, and you can post your question, and your question will be voted on and asked.
Awesome. So are we ready for our next talk? It's so nice to have everybody in the same room. It's less quiet, you know what I mean? Anyway, so our next talk, he's going to be talking to us and taking us into a journey of like code, JavaScript, CSS, and HTML, and just blurring the lines between art and code.
And we have Martin. Martin is a mapper, reducer, I just really want to say this, creator of JSFuck, and co-founder of UB Labs, sorry. And he used to organize JS Unconf.
So please welcome to the stage, Martin.
Is it working? Yeah, now it's working. Okay, perfect. Thanks for the intro. We're going to start quickly with our red thread somehow. This is about data loss. You saw this in the description. It's a bit cryptic, but you will see a pattern here during the talk because we're going to focus on some parts of the Greek mythology, and we have the maze or the labyrinth as a topic through the talk. You will see later what's this about. So let's get started, and let's unveil the topic. The topic will today be creative coding in different ways. I talked to many people already, and they all have different ideas, and I try to cover many aspects of creative coding now during this talk. The first one I'm going to show is quite old. It's 5 years old. It's a thing that I show off at JSConf in Berlin 5 years ago. It was some script that's exactly 1,024 characters long, and it's an HTML page, and once you run this in a browser, you will see a spinning globe inside of this page. So that's something that we call a Quine. So a Quine is a computer program that outputs itself, and this is a special version because it's also modifying itself, and you see this, this pattern going on. Yeah. Another thing is this competition just ended for 2018. It's the 10th time the JS1K competition took place. And this is a competition where people can do something in exactly 1K of JavaScript with no external resources. And I'm just going to show one example because I think it's a quite good fit here. It's by Johnny Gikanga. He's quite new in the scene. And he created an animation showing the Northern Lights. And I picked this because we are waiting for this. So at least you saw it like virtual here, like virtual reality. But I'm really hoping to see it the next days. So it's really cool. You see some strange pattern going on. I'm not going to go into the detail because we don't have much time, but if you're interested, they just close the competition, and you are able to like walk through every demo and see what's going on in the background. Yeah. A second topic I want to talk about is code golf. Code golf is it's a mix of art and sport and programming, because from the term golf, you try to hit the ball into a hole with the least amount of strokes. And what you do here is you have a problem that you try to solve in the least amount of characters. So you're trying to shorten it as much as possible. And a good example here is this maze. Who knows this maze? Pac-Man, right, Pac-Man. So this is an old game, and an idea or like a theme that we came up was we would like to create this Pac-Man game, but with the least amount of characters that we have. And one thing that you usually start with is reduce the graphics. So instead of this nice little Pac-Man icon, we only have an X and a dot. So that's still like you are still able to distinguish between characters, and this is the final output. So you see the words are the hashes, the dots are the things that you're going to collect. The 0 is the ghost, and the X is Pac-Man, which you can play using the cursor arrows. So you can move around, you can collect all the dots, and then it happens once you hit the ghost, the game is over. But this is like all you can do. It's a really minimalistic aspect here, and the source code is only 348 bytes long. So, but this was maybe 2 or 3 years ago. It's not using some special ES6 things, so it could be even shorter, but I just leave it like this. Another thing is reverse code golf. So instead of doing something small in the result, we pick only a subset of characters and do something big. And it's another project I'm quite famous for. It's JSFuck, JSBeep. It's the correct word here on the stage. And here you can, what you can do is you have a web page where you can enter your JavaScript, Alert1 for example, and it will output code that you can take and execute somewhere, wherever you like. And it only takes brackets, braces, plus and ampersand as the output. And this will be the Alert1 in the end. So quite long, but quite interesting to read. I have to show this because it's like a fundamental principle that we're going to see in the next example, how this works behind the scenes. So what we're doing here is if we have not an empty array, it will be converted into false. If we have not an empty array, we have true. And if we then add another empty array, which is the same as an empty string, then we get the string false and the string true. Yeah? And what we can then do is pick several characters out of these words. So 0 would be a plus and an empty array, and we got the character T, we got the character R, the character U, and the character E. And if we then take different words with different characters and combine them, then we can join them again and create new words out of this. For example, alert. And that's something that I call playing Scrabble with JavaScript. So you have some basic types like false, undefined, true, object. There's also undefined, as I mentioned. And you can combine these characters to new words. And one word that's super important here is the constructor. So we can get a constructor as a string. And if we then take this constructor and place it next to an empty array and call constructor, and then passing something, is something quite interesting, because the first place will be empty array constructor, which is basically a function. And if we have a function and then take the constructor, then we have the function constructor, which lets us pass arbitrary code like alert1, which is basically eval. So you can combine this and like execute code without writing it. Another example that recently came up is similar to JSFuck, so it uses the same mechanics behind the scene. It's symmetric JavaScript. So this is also valid JavaScript. It runs in alert1, simple example, but every column that you see is symmetric. And if you do just 3 rows here, then you see, okay, the first row is the word, the second row is the character, index, and the third row is just to add these characters. Yeah, so you get this alert again. That's it for the first part. Was there something? No. I'm going to show. Oh, so here it is. As you might have read in the description of my talk, I used the Daedalus writing in the Latin alphabet, but also the Greek version, the original version. And the next part of my talk will focus on different writing systems that we have. For example, Greek, we have Cyrillic, we have Arabic, we have Korean, we have Hebrew, then we have Japanese, and the last one, who knows the last one? There was something. It's not Klingon, similar. It's Arabic, which is the most used language in the Star Wars universe. So I created a website that's able to convert your input into Arabic JavaScript. And you can type not only different symbols, you could write this as Icelandic characters or runes with your axe. You can hammer them in. And you will get out an output that looks like this. So it really looks like from ancient times. But it's also doing an alert one. And you can choose different symbols, different alphabets, and it will all do an alert one. And for example, this is Greek. And quite interesting to do this because it uses this Teluga writing system. Not sure if you heard about this. There was this symbol, the first one. Once you have this on an iPhone or on a Mac, it will crash. And while preparing my presentation, I had this somewhere and in a file system, and I took some time to get it back because I had to install some software to not display it. So, so this is deadly JavaScript for some machines. I like this personally because it uses German words like Ja, Nein, Schnitzel, Bier. But this is Arabic, so it's really close to what they have in the Star Wars movies, and it looks super cryptic, so you might see this instead of React code in the next Star Wars movie. Yeah, but you can play around with that and make it more graphical, like only using underscores, or only using the upper half of a vertical Kana repeat mark representation to write variables and assign them with other variables. So how does it work? This is a simple example where I used the Latin alphabet. Yeah. And here you see they're quite distributed over the code. And in the end, it's the same principle as I showed you with the JSFAQ code. So you have strings and get single characters out of this. Then you combine them to get the constructor keyword, and then you also have a way to get alert in there and execute that. This is an odd one where I use Hebrew, and once you have Hebrew symbols in the code, it's funny because the browser might switch depending on your browser, the writing direction. So this code is not read from left to right, but from right to left, which is super interesting in a way. Next one, next step. We've seen these variables, and there's quite some interesting ways of hiding code. Let me think, it's the Hangul alphabet, which is used in Korean alphabet. They have a filler character, and this filler character doesn't take up any space and it's invisible. But you can still use this as a variable name in JavaScript. So what you have in the end is code that looks like this, or actually it's this. And it's an odd version. I shorten it a bit. So this is alert one, and I call it the invisible alert. It still has some character, but you can't read what's going on here. Yeah. You can do crazy things with that. So when you see triple plus signs, there's something behind the scene where it simply adds characters together. You can have something that looks like a fat arrow, but is an assignment of an arrow function. Or you can put // into // into your code that looks like a regular comment, but is a regular expression. And So what I did is I combined these two aspects and have something that looks like a comment in the beginning and does something. And there's a little pink empty string in the center of the code. You will later see what is going on. And if I reformat this, I put this into a script tag. So this is the source code of an HTML page. And once you execute it, it will show you the void like graffiti in an animated way. Okay, the missing link is here, how to write invisible code. And this is quite easy to do, so you can use fillers or something from the first ASCII page that still takes up space, but on a second ASCII page, there are a lot of device control characters. And these device control characters, if you use them in the code, they're not visible, and they don't take up any space in most of the browsers. And you can wrap them in a string and have a small snippet that will unescape them. So this is the code we are going to use. We have an escape of this invisible string. We're going to replace every third and sixth characters and join them together with an X in the front, backslash X in the front. So it's a hexadecimal escape. And just to give you an example, these are some control characters. If we then use escape, we get this percentage sign in front of the numbers. We strip them away, and then we combine every third and sixth characters and escape them. And once we have that, we also have the other one. Thank you, thank you. It's just the beginning. Yeah, this one is crazy. Let's go back to the Greek mythologies. I showed this labyrinth. Not sure if you know the difference between a maze and a labyrinth. The maze has many ways, and a labyrinth only has one way to the center. And in the center, there's the Minotaurus. And the Minotaurus is a creature. It's a mix of, it's half man and half bull. And he's eating boys and girls that are sent into the labyrinth. And the thing that I like here is it's a creature that has like two aspects. It's min, and it's also a bull. And there's something similar in programming, which is called polyglots. And a polyglot is a computer program that is written in different languages at the same time. And depending on the compiler, it will execute something different. So what I thought of is, can we build something that is a JPEG, an CSS, a JavaScript, and an HTML file at the same time? And I created this page called Inception. And this is, when you look at it, you have this image in there. We need to go deeper. And at the end, you see some crazy characters. And what it does, it's basically like one page with 4 different types in it. It's hard to explain. I'm trying my best now. So what happens is that the browser opens the file and will run it as an HTML page. This HTML page has a script with a source to a hash, and the hash will force the browser to load its own source code as the JavaScript. This JavaScript then will write a link tag, also pointing to hash, and interprets it as a CSS. And this CSS file then has a background URL, which is empty, which also takes the same page again and renders this in the browser. Okay, maybe a bit more in detail. So we have the HTML, which is content type text HTML. So whenever we open the document for the first time, the content type is an indicator for the browser what to do with that. So it's an HTML file. And then we simply have something going on, but the most important thing is that we have a tag, our own tag that's called Inception. And another thing where we have a script tag with a char set to Latin 1, which points to the same page. And this one is now loading the JavaScript. And you see the first variable here is a bit strange. It's a bit like Julia, and it's an object with the property inception that is with the value of tt. And yeah, and the next line is something strange because it will multiply inception with an object that has a property that calls the function URL. So you might see the problem here because JavaScript will fail if it's not valid. And in this case, it would not be valid because it doesn't know the URL function and it doesn't have inception as a variable. So what we do later is we say var inception and function URL, and this will hoisting the thing to the top, so it's valid. And then we have some comments that will like hide code that we don't need, but make sure that it's valid. And the most important thing here is that we're going to write a link tag pointing to the same page to load a style sheet. So this is the style sheet now. Same page again. The first one is a strange selector. So it tries to find a tag with this strange name, and then has this other equal sign selector thing. It's not defined, as far as I know, in the spec, but it's valid syntax, so it will be simply ignored what's going on here. The third line here, this is something that's not valid in CSS, and what's happening in CSS is once the browser scans it and finds something that's not valid, it will break and not execute all the following commands. So it will only focus on the second line here, which is that every tag inside of our inception tag will have the background URL with the same page. Yeah, and this now loads the same page again, the JPEG. The most important thing is here the beginning and then the image data, and everything that you see in between, the yellow part, is metadata that is there and will be simply ignored in the display. And if we look at this in the hex editor, then it looks a bit like this, but we can zoom in to see what's going on. So FFD8, FFE1 is the identifier that says this is a JPEG. And the following 2 bytes, OD, 3D, they define the EXIF header size. So they say, okay, we now take up 3,389 bytes header where we can do our things that we want to do. And if we then look at this hex presentation and convert it, for example, to ASCII, then we see this is already looking familiar, but we have some ampersands and this question marks, and that's because ASCII only has 95 symbols defined, and this is out of the defined range. But as you remember before, we forced the Latin 1 ISO 8859/1 encoding, and this will turn our first hex codes into something that's a valid JavaScript variable. Yeah, that's it. So this is the page that you will see in the end, and I call this Inception. Thank you. Daedalus. Maybe I have to explain a bit more. So this is an old picture about Daedalus. Daedalus, he was the inventor of the first labyrinth on the island Crete. And he was, I'm not sure if you know the story, but he also has a son, I think, Icarus, and they tried to escape somewhere, and he flew too close to the sun and fall into the sea. So it's a bit tragic story. But what I want to take here is later Theseus was the one who got into the labyrinth and tried to kill the Minotaurus. And if you studied computer science, you might have come across a Theseus project, not sure, but I'm going to show you in a second what this is about. But what I wanted to do is to draw a labyrinth or actually a maze in this case, because it has many ways, with JavaScript. And this is the layout I've chosen. And instead of words, I had code. And this code is also valid, and you can copy it, paste it into the console, and it will output a new and bigger maze. Yeah. And to take this some steps further, I first tried to minimize it. So this is now the whole program that you need to generate this maze. It's only 133 bytes, and it was originally created by EDC65. I don't know his real name, unfortunately, but I was able to golf it down so that we can play around with that. And during my studies, I came across a project called Theseus, and Theseus was a project, a quite early project from Claude Shannon. Not sure if you've seen this, but he is known as the father of the information theory, and he always created crazy machines. And one example, some people say the first example of machine learning that he created was the so-called Theseus project, and it already had two different phases. So the training phase and the testing phase. And it all was working mechanically in 1952, I think. So he could set up a maze, and there was a mouse in there, and the mouse always tried to explore the maze and find the goal. So it's a marble, and this marble, once it hits, it's the goal. So this is the exploration strategy. So you see it's bumping against the walls, moving back, and try to find this. And there's a second thing. So once it hit the goal, wherever you place the mouse, it will go straight to the goal without bumping against walls. And what's interesting here is the algorithm behind, because it fits on a sheet of paper. And to sum this up, the exploration strategy is it reads the direction where it came in, then it will rotate by 90 degrees, move the mouse, and go back if there was a wall, and do it again. So it will always try to return by 90 degrees and then try to move again. Yeah, this is exploration strategy, and this is being proved that it will always find the goal. Once it has the goal, it switches to something called the goal strategy, and it's the same thing, but without the rotation part, and it won't hit any wall. So it reads the direction where it enters, or last left the cell, and it moves the mouse. So it will go directly to the goal. Yeah. And to put this in the code, it's only 256 bytes. The first part is to create a random maze. The second part is to solve this maze. And this one is only to render the maze. And to see what the output looks like, it will draw a maze with hashes, and the O's, they are the way out. So it will create a maze and also solve the maze. Yeah. I have an animation to show you what's going on. So this is the representation that's used in the background. This is the final output, and this is a more visible representation where you can see how it turns the arrows around and always turn them by 90 degrees until it finds the goal. Yeah. 5 minutes left about. That's great. So this talk was all about creativity, different aspects about creative coding, how people can squeeze code, how people do visual stuff. And one thing that's quite important here, and it's super interesting in our language that we use in JavaScript, is the community behind. Because everything that you see is, you can always look into the source code and see what's going on. In the 80s, there was this demo scene, and they're always trying to hide their source. So they always try to not show how they did it. And this switched in the JavaScript community, because everything is visible. And there's also a nice Slack channel if you want to get involved into this. It's jsgolf.club. Once you're there, you have a form to sign up. It was established by Maxime Auxier, I try to get the names right now. And there's a lot of discussions going on. People come up with new ideas, people discussing how to improve stuff, and it's super interesting. And I want to use the last 2 minutes, 2.5 minutes, to show you some more demos, because another website is popping up by Andres Lovzelvik. It's called Twitter. And what you can do here is it's similar to JSBin. So you type in some code, and the update will be instant once you type, and you have exactly 140 characters to do something. And what they also do, they provide you some shortcuts. So for example, for Sinus, you have, for math Sinus, you have the capital S, you have access to the canvas with the C. So there's also some savings, and then you have exactly 140 characters left to do whatever you like. So it's a great way to play around, and it lists you all examples, and you can vote on this. And you see, for example, a game of life done in 140 characters. You see a 3D fish swimming in a pool. That's something I was working on, so we tried to find a shortest way to render ocean waves in only 66 bytes. And we have raycasting that fits on a business card. That one was by Sigve Farstad. Oh no, that one was by someone else, sorry. Yeah, Sigve Farstad. We have this crazy tunnel going on, a roller coaster, and really crazy examples, star fields. It's like CodePen, you can discover them. And what's nice is that you can, once you found something that's interesting, for example, this piece where it will draw a world. So it's basically it's a bitmap encoder in 140 byte that draws the world. You can use this and create your own forks out of this. And I create something different here. So I had a spinning globe made using some math and sinus and cosinus formula. And another one came up with another spinning sphere, and we tried to reduce this until we only had 77 bytes. And I said, let's combine this one with the bitmap rendering, which took some time, but in the end, Matthew Henry came up with the spinning world in 140 bytes. So he managed to create a bitmap that looks like the world map on a spinning sphere. And this was not the end, so I tried to do something different with that. And in the end, Jai Chan came up with the colored version of that. So it still has some glitches, you see, but this is absolutely crazy. So the one I started with was about 500 bytes that you saw in the beginning, and this is only 140 bytes. And you learn a lot when you cross these examples and read the comments about it. Yeah, that's it. So check out TwitterNet, and I also would say it's now your turn to be creative. It's some people ask why I do this, and I would say it's super helpful not only to learn more about the language, so you discover new ways of doing things. It also helps you to organize code, because in the first place you don't compress it, you have to lay out the code really nice to keep track of it. And one thing that's also really good is that you have to focus on a problem, and you have to break down the problem and really focus on the minimal aspect in there. And this is something that I always take out of this, and I want to give this away to you and say, okay, try this out. So, thank you. Thanks for listening. All the examples are up on my website. I'm going to tweet about the presentation in a minute, and you can also, if you download this, all the examples are clickable, so you will be redirected to the original URL. It won't break your Mac. I'm a good guy. This is not about bad security. It's about creative fun.
That was amazing. Thank you so much. I am supposed to come up with questions, but I'm so mind blown that I actually can't think of any. Okay, no, I got one. if you can have dinner with any character from Greek mythology,
From what?
Greek mythology,
Oh.
who would you pick?
It's a good question. Actually, I would have dinner with Perdix. Not sure who knows Perdix.
I don't know.
So he's the nephew of Daedalus. Daedalus was really a skillful man, but he has a nephew, and he taught him all the things that he knew. And then he saw that Perdix was even better than him. So he was the one who created the circle, the compass, and crazy other things. So Daedalus tried to kill him. But he was
Sounds like a
saved
great guy.
and turned into a bird, but he was really good.
You
Good
must
guy.
be fun at parties.
Yeah.
Well, thank you so much for a great talk and lessons on Greek mythology. Thank you.
Thank you. Thanks.
What happened to your suit, Florida?
Someone promised me that they'll make my web app fast.
So you traded your suit
They
for
stole my
fast.
suit and told me to try this one on, and I can't find it anymore. I don't know what to do now. I feel like my life's no meaning.
Okay, well we can try to find your suit later, I guess. That's very unfortunate. I'm sorry.
I know.
Don't cry. It's okay.
I heard it's really hip in Europe, though.
Tracksuit?
I heard they look like
In
a
like the
European
80s,
dad.
maybe, but
Beautiful. Thank you very much.
I probably do. I maybe look like a dad already.
Mhm.
Anyway.
well, did you know that Webpack 4 was out approximately 120 hours ago? That is 5 days, I think, right?
Yes.
It's supposed to be faster, easier, and better. I know that sounds generic as hell, but I don't want to spoil the surprise. And also, I looked at the changelog, and it had 203 bullet points. So I don't think I'm going to do a very good job summarizing it, so I'm going to leave it to Sean.
So Sean is a program manager at Microsoft. He's my first suspect on who stole my suit. He probably has it
wasn't
somewhere
me.
in his talk. So I'm going to go look for it. Anyway, he works with companies to change their culture on best practices on web performance and open source software and also emerging technologies. So please welcome up to the stage, Sean.
What's up, everybody? How's it going? That last talk was really freaking great. And I wondered to myself, I'm like, I maintain this web compiler, and like, how many like tiny character tricks could we take from this? But anyways, maybe that's for a minifier. So yes, thank you. So the title of this talk is Webpack 4, the state of the art. And so for those who don't know me, I am Sean Larkin, and so I'm a project manager or program manager at Microsoft, working at Microsoft Edge and Edge Dev Tools. But you may know me as being one of the maintainers of the Webpack core team, and also spent time working on the Angular CLI, and just a general evangelist for open source sustainability. And then now, kind of with my involvement through Microsoft and Webpack, helping represent you all at the Node.js Foundation for modules, and also WebAssembly in their community group. So a little bit about myself is I'm a technical support rep gone rogue. I got tired of not being able to solve people's problems, and so I started learning AppleScript. Like, who wrote AppleScript? Like, yeah, like that was my first programming language. And then Ruby, and then Objective-C, and then finally I found JavaScript. I also like woodworking and Internet of Things. But like I said, sustainable open source practices is one of probably my latest passions that I've been following. Now, you can find me anywhere, like anywhere, in most places, with @thelarkin. And so if you wanted to tweet this out right now, I'll give you a second, take your time. There's no rush, but you can find me on any of those places. So back to the talk. Okay, so Webpack 4, the state of the art. And state of the art. So, like, I just wanted to pull up a little definition, and hey, is that how you'd say it? A stand off the list? Is that the Icelandic version of that? I'm not sure, but you know, we're talking about the recent stage of development, or I don't want to call what we do avant-garde, but at least, you know, the latest release and what we're talking about today. And so, you know, like it was mentioned, we did just release Webpack 120 hours ago. And it's here. It's in latest. Webpack 4 is out, and you can get it today. But I want to talk about what Webpack 4 represents. And so, for the first time, we decided to take and give our major releases a code name. And so this is called Webpack Legato. So you might be like, what? Legato? I'm a music major, so in college. So anybody else did music? Okay, so you understand what legato means. It's to express notes in a flowing manner without gaps in between them. But we got this term from our major sponsor, Trivago. So we wanted to give the opportunity for one of our largest sponsors to name this major release. And so this was kind of their explanation. You know, at Trivago, we usually give our projects a name and a musical theme. So, for example, their old JavaScript framework was called Harmony. Our new framework is called Melody. And on the PHP side, they're using Symfony. And the top layer is called Orchestra. And so legato, meaning to play without gaps, expressive through each note, to them really embodied what it meant to have Webpack 4 you know, in their build system, and how it ties everything together. And you know, before I go on and explain more, I want you to just look at one of these slides, or to each of them, and if you see your company there, or yourself, I just want you to stand up right now. So if any of this is you, stand up. I know there are many, please. So I want you to look around, and I want you all to give them a round of applause, because this is because without these people, we would not be here today, and Webpack 4 may not exist. So I just wanted to take a second and recognize those people. So, you know, we wanted to kind of create this higher level story about what Webpack 4 meant. Meant for our users, meant for us. And so, you know, the first thing was smaller builds and faster builds. And the second was modernization. And then finally, probably one of the most important, well, I mean, all of these are really important and not mutually exclusive, which is developer experience. And if I talk about smaller and faster builds and we try and break it down, you can kind of categorize it here. So like, to have a smaller build, you're going to need to do more analysis on the code. And you're going to have to process more of the module graph. And then for faster builds, though, you're going to have to do less work and reuse existing work that's already been done. So these are kind of conflicting. But for faster builds, we completely re-architected the way that we define what a chunk is. And a chunk is just the in-memory version of the bundle UC created. But we also added additional features like Uglify.js. We're going to be using it in parallel and caching it out of the box. And we also modernized a lot of the pieces that we had in just old ES5 object syntax, and we moved to using maps and sets. But specifically, I think one of the most important is the migration of our plugin system. We wrote it completely from the ground up. And now we have what are called hooks, which create monomorphic code. And we lazy compile them. And I want to actually take a moment to explain, well, what does this even mean? Who here is familiar with monomorphism or polymorphism? Okay, so this may look familiar. So this is an example of one of the methods that is available in our plugin system prior to rewriting it. And so if you see here, this method is what certain classes in Webpack will call, and plugins are listening to this event. And what's passed in is a arbitrary like event string. It's like an event emitter, if you've ever used it before. But the problem here is that this is polymorphic. It can be any amount of arguments, and there's no way for the JavaScript engines to optimize this. So, you know, our initial answer was like, well, why don't we get clever and just make separate methods with single arguments for each of them? But that was not going to work. One, because we could have a plugin system that's ginormous. You have infinite amount of different event names and argument types that can be passed in. And so it's unmaintainable and not really a great contributor experience. And so it's like, how could we solve this where we're creating monomorphic functions, but they're unique, and you know, we don't have a billion of them that we have to maintain. So we use the technique to lazily compile based on what is listening to these events. And I know I'm going a little deep here, but it might make more sense in a moment. But you can see at the bottom, we're literally just composing a bunch of strings that are JavaScript that compile to these hooks, and then we evaluate it. And so like a really great resource if you're interested in this, and I'll try not to butcher the name, but Vyacheslav Egorov wrote a great explainer article that you can go to and take a look at it to understand how this accomplishes monomorphic code. And if you're on Twitter a lot like myself, you may have seen this article that was like, hey, you may not need, you know, Rust and WebAssembly to speed up your JavaScript. Well, it turns out, I was like, oh, that looks pretty familiar. The code that he showcased. And look, he's doing the same thing. So the point is that we can create this monomorphic code, but we're doing it kind of evaluatively or lazy compiling it. But please do not do this in your normal projects. This is, you know, there are some parts of Webpack that execute 19 million times on large code bases. And so everything is in the hot path for us. And so just as Benedict Moyer says, or V8 Senpai, please don't do this. Please don't. But so, like, what did this represent to us? And so, on most Webpack builds, we saw it get 98% faster. So, 98% of the build time was reduced just by people upgrading to Webpack 4. 98. Yeah. Yeah. And you'd be like, Sean, you're lying, stop. You embellish all the time. And I'm like, well, it turns out that we have people who are reporting 6 hours of their build times on Webpack 3. Actually, it was 9 hours, but he stopped it at 6 on this run. And so we were like, we have an idea. And after showcasing this in the Webpack 4 alpha, we found out 17 minutes. 17 minutes from 9 hours. So, like, there's the URL. You can go to it. I'm not lying. And just to make sure, so that people would be like, Sean, you're still lying, once we got into our release candidacy, I decided to, you know, play a little game to see, hey, one, could we get people to upgrade to the beta so that we could catch early bugs, warning signs, things like that. But two, is this like speed boost really, is this for real? So, yeah, I shot this out, and like, we were seeing 75%. On some cases, we were seeing 90%, 80%. And so, it's the real deal. And so, you know, that build speed, you know, to sum it up, we were able to accomplish that first piece in what our goals were. But then we still had smaller builds. Now we had to do something basically completely opposite to what trying to get a faster build will do for you. So the first thing that we tried to implement, and we were able to do so, is JSON tree shaking. So if you ever use JSON with Webpack, you'll notice that in version 3, it would bundle all of the pieces that you would import into it. But we found out that really, like, JSON is just a stricter set of what JavaScript is. And so we could treat it like an ECMAScript module, and only the pieces that are now used will actually will stay in your code. And so in this case, you can just see we're just pulling in and importing one property, and that's all that actually compiles when we minify the code. We also have a feature, well, I'll explain the problem first. So according to the ECMAScript module specification, or the Harmony module spec, when you have multiple exports inside of a file, every single one of them has to be evaluated and executed to ensure that they are not creating side effects against each other. So what does that mean? Well, if Lodash is exporting from a file, essentially 1,000 exports, each one of them has to be included into your bundle. So what we did, and you can see that here in this tiny example. So what we did is we created this trick. We had to tell the compiler some way like, hey, there are no side effects here. You can go ahead and ignore those properties. And so that's what we did. We created the side effects property, which now we're asking library authors to include in their package.jsons. Because what Webpack will do in production mode is it will look for the presence of this property, and it will simply prune it out. And in fact, it actually makes builds faster. When we were in the beta stages, we found that our production builds were faster than the development mode builds because of this feature. Because what you're doing is you're ignoring tracing those parts of the graph because you know they aren't actually used. So in this case, we saw something like in Webpack 3, 200 KB of minimized code actually turned to 1 KB. So really, all you need to do if it's so easy. All you have to do is just tree shake, mangle your exports, scope hoist, minimize, and then package authors have to set side effects. No! That's ridiculous. You shouldn't have to do any of that. And that kind of gets into what developer experience is about. All you should have to do is freaking run Webpack. And so out of the box, now in Webpack 4, we default to a production mode. So all of those things you saw in that bullet point, they just happen. And so developer experience to us meant we need to lower the barrier to entry to people who are trying these tools for the first time. Not everybody understands the rigorous and obnoxious history of JavaScript modules and where they started and where they are now. And we also need to have better defaults. And thanks to libraries like Parcel, we can now coin something like zeroconfig.js. And to us, zeroconfig doesn't mean, like letting you do whatever you want and shoving it into one package and then hoping not the feature that you don't use breaks and causes a major breaking change. It means being able to actually extend a base scenario to your users so that it can BYO or bring your own zeroconfig.js. And so this is really the line that we wanted to cross. So, by default, you don't even need a Webpack config to use Webpack 4. Every property has been defaulted. And what the future... yeah. Now, what I'm trying to say, though, is that not everybody will end up, just ripping out their Webpack config. Because the power of Webpack is deeply rooted in how extensible we are. And so, instead, why don't we extend this idea? So we also created this feature called mode. And so mode is a property on the config or a flag that you can pass in the CLI, and we default to production, like I said. And what it represents is that for development, you're going to want to have tooling for the browser. You're going to want to have really fast incremental compilation. And you're going to have better error messages that don't take up an entire console. And then for production, we're optimizing for size. We're optimizing for the right kind of source code. And we're optimizing for file paths that are understandable but don't leak, information to the people using your website. But it also means getting rid of things that used to really cause us problems, like the Commons Chunk plugin. In Webpack 4, it's gone. We've replaced it with an API that does much of this out of the box by default. But on top of that, we have properties that give you more control than Commons Chunk did. And then finally, build speed was something that we took so seriously that we wanted to be able to profile and analyze really deeply any long-running build. And so we worked with Sam Ciccone from Google, who helped us implement a special profiler that allows you to see every plugin and how long it takes right inside of the DevTools timeline viewer online. So now you can literally see, and I mean this information may be more valuable to us, but it allows us to just say, hey, pop in a plugin and send us the events.json file. And it's really useful for those who are creating plugins themselves and trying to analyze interactions. And that kind of leaves us to, the modernization and the re-architecture. So, one of the most important things that kind of held us back in Webpack 3 is that we treat everything as a JavaScript module. But we also were championed with being able to implement WebAssembly as a first-class citizen. And so this gave us the opportunity to remove all of these everything is JS hacks. Or it allowed us to actually implement WASM as a module type, which allowed us to also implement JSON as a module type. And it gave us JSON tree shaking. And then what we're working on right now is HTML and CSS module types. So we had to take and remove all from, our module factories is what we call them, all of the code generation system that was specific to JavaScript, and we've, isolated it. And so now, with WebAssembly as a first-class module type, you have code like this. This is a newer library called Walt. Who has heard of Walt? It's a subset of, I guess you could say TypeScript. And it allows you to write a very JavaScript-like syntax, as you see up at the top. And then all you have to do is import it, just like it's a JavaScript module, into your code. And you have used WebAssembly without doing anything else at your fingertips. This is probably one of the most exciting things to me, is that you want to use A-Frame, or you want to use these things. Now what these library authors can do is instantly compile a WebAssembly module. And if it's available in the package, Webpack will consume that instead of the JavaScript. And so you get the 10x speed up instantly at your fingertips. And so the other pieces were dropping Node 4. So Node 4 is no longer supported for Webpack, and Node 6 is our minimum version. But this allowed us to convert the rest of the code base to using ES6 features. It allowed our code to be more readable, easier to change, using syntax that people understand and contributors want to actually leverage. And now, by using this new code, V8 actually has a great test bench for optimizing paths that aren't as hot yet, that should be. And I mean, as it was said, we're just scratching the surface on all the different changes that we've made. And so, smaller builds and faster builds, modernization, developer experience, that is where everything was rooted in. And so you might be like, all right, Sean, this is great. How do I migrate? So right now we have the PR pending for our migration guide. And I'll talk about it a little bit more. And then what about for frameworks and plugins? Well, we've been working, ever since we released our alpha, behind the scenes with Create React App, Preact CLI, the Angular CLI, Vue CLI teams, to make sure that, and we put extra focus on them to ensure that they had a steady path and there weren't blockers for them to test early. But for right now, until we get that migration guide merged, I'd say jump on our Medium publication, or submit an issue and ask how you can help. And like I said, the Angular CLI is actually going to be now supporting it in their next major release, which I believe is like next week. So look to have that automatically out of the box for you. And then, you know, shameless plug to me, you can always jump on my Twitch live stream, which I do 2 times a week. And you can ask me questions anytime. We work with people just to help them migrate. We also get people to contribute to the code base and, you know, submit their first PR ever. And even more so, we wanted to make sure that this worked at scale. And so Ken Cha, who is surprised appearing in these slides, you know, he is one of the lead engineers for the Outlook web app team. Well, as of, I think, a few days ago, or was it yesterday, the Outlook web app is now using Webpack 4. Not only did the size of their builds instantly shrink without making any changes, but their build times and their inner dev loop jumped from 100 seconds to 20 seconds. And on a 150-person team, we're talking millions of dollars of dev time saved. And so we're hoping to accomplish that not just for, you know, Microsoft and the Outlook team, but by vetting it and dogfooding it in that way, we can ensure that it's a great experience for you. So what's next? Like, what's beyond Webpack 4? So the things that we're going to focus on are finishing the CSS as a module type, HTML as a module type, URL and file as a module type. But as you can see, what this means is you don't have to use Extract Text plugin anymore. You might not even need, yeah, I know. You might not even need to have a CSS URL file loader. We might just have this supported out of the box as a module. You'll be able to say hello to CSS code splitting, something that doesn't exist today and actually, you know, causes kind of a pain point for, you know, browser and load times. But you could also have HTML as an entry point. And then the other big feature that I'm really excited about, which is called Webpacking WASM Part 2. So, you know, when we introduced WebAssembly as a first-class citizen, we kind of can, you know, the module type is called WebAssembly/experimental. And so the first thing is to stabilize it. But then we're going to go ahead and add a bunch of the features that we already have on JavaScript and apply it to WebAssembly. And so this means tree shaking. You can do that. Dead code elimination. Scope hoisting WASM modules. And so this is super exciting because now WebAssembly goes from being something that you can use once or twice to using it just like any other JavaScript module and not taking a perf hit or a size hit or a runtime hit. And then maybe something that's really special for me is presets. So like I said, you know, bring your own zero config JS. These are just examples that I played around with in a prototype. But what if it would be just this easy to say, at Webpack can use Babel if exists? You can install that package and it just reads your Babel RC and throws in Babel loader. What if, as a package author, you have these composable parts that you can share and leverage? This looks very similar to Babel if you understand their package structure. And you know, at least I took the inspiration in this prototype to kind of leverage it. But can use TypeScript really could just be, can it resolve TypeScript and can it load it using a loader? But the point is that this is how you can extend zero config. So with a couple packages that you would add, you still don't need a Webpack config. Yeah. Thank you. And so what's beyond 4.x? So those are the kind of like the things that we can do right now without causing a breaking change. But what's beyond that? So one of the most important things that is lacking for Webpack is that we don't have a fully persistent cache. And so that's the first one that we're going to be working on. And so we actually kind of worked really closely with the author of Hard Source Webpack plugin, who has probably the most experience with our code base and, you know, disk caching. And so he wrote up a specification, and you can take a look at it on GitHub. I think it's under the Webpack 5 tag. But also things like multi-threading our builds. Actually, when we saw the presentation, or when I saw the presentation yesterday about having workers be native, that was really exciting, especially to us who wants to be able to have something right out of the box from Node. But also have all of our experimental module types become stable. And then what if we could bring your own module type? What if you could write a module type that makes you not even need a TypeScript loader? What if you could take those types and treat it as metadata and allow it to do static, program flow analysis and make your code even smaller? I see a future where you want to use TypeScript with Webpack because it creates smaller bundles. And so I really have see a promise for bring your own module type. And I mean, to be honest, these things are just a reflection of what you asked for. And so, did you know that every single one of you, if you have a GitHub account, can go to webpack.js.org/vote. And every day, even not as a contributor or a sponsor, you get one piece of influence every day that you can vote on a specific feature. So, I mean, literally we put the power in you all because that's who we represent. You saw our sponsors and backers. We're a grassroots project that represents exactly what it means to have web performance and developer experience without making a sacrifice to each. And finally, we shipped Webpack 4. What did we take away from it? One of the things that we announced when we released the release candidate was that, we said, here's 30 days, plugin and loader authors, you get 30 days to upgrade. We're not going to break any changes between our RC and final. And that was great for our team, who owns a lot of the core plugins and loaders, but it was a lot harder for people who, third-party plugins. And so I think what we're going to do is focus more on providing a migration guide for loaders and plugins, and even just general updating versus having a time window. And I mean, overall, like I just said, I rambled about it a little early, but we are, what we do is exactly what you asked us to. And so we see this year of JavaScript as being, no more talk of this fatigue. But instead, it's having this mindset of embracing the changes of our technology that are so beautiful in JavaScript. Some joke that we see a new framework every 2 weeks, but that's the most beautiful part of our language. In what other language do you get to use syntax that doesn't exist yet? Without a VM, for you Java people. Because that doesn't count. There is no other language. It's a JavaScript renaissance. And so we embrace this. We call it even a growth mindset at Microsoft. And so we ask you to do the same. And help Webpack just not be yet another build tool. So thank you guys very much. Oh yeah, and try Webpack today.
Thank you so much for that talk. That was awesome. I
Thank
still
you.
didn't see my suit in your talk, so I guess it's
I don't
not
have
you.
your suit. Well.
Oh, okay. I have one question. I think Vanessa also has
Okay,
one
go ahead.
question. My question is, I use Webpack on my day-to-day.
Yes.
And I know that if I install Webpack 4, I'm going to have to deal with dependency hell for a few hours. What are some of your wise words on dealing with those things?
So I think the best way to get started is, so we tried and created like a unified channel for, talking about the things that we've been doing, and then even provide resources before it gets into our documentation. So one, you can just blast me on Twitter and be like, Sean, what do I do? And I'll usually send you one of these resources, but you can go to medium.com/webpack. And the last 4 or 5 posts that we've put in have literally just been about understanding the breaking changes, how to migrate them, and then just other things that might cause problems. But beyond that, we would say, either just an issue on GitHub or reaching out to us is the best way, because we want, we try to be as available as possible on Twitter. And that way we can, forward you resources or other things.
Awesome. Thank you. You want to ask your question?
I have a serious one and a not serious one. Let's
Okay.
go with the serious one first. I think Webpack is one of the most starred, maybe, open source project on GitHub. It being, a really big community effort. what would you advise to someone who want to get involved, who any entry-level way to
Absolutely.
contribute?
Yeah, so one of the things that we really focused on is trying to create kind of an inclusive and diverse community that doesn't feel intimidating. And so although our code can be a little intimidating sometimes, the first place we say is check out the README, which has all of our contributing guidelines, our code of conduct. And then also take a look at, on our Medium publication, we have a section called The Contributor's Guide. And so it's a 3-part post series that I worked on to kind of give you like the whole overview of like what to expect. And if you like certain things, try this package out. Because we have, across 2 organizations, 100 different packages. And so the whole point for us is that open source is about people who have a passion for something, regardless of where they come from, and applying those skills to a way that makes Webpack better. And so we try and find different opportunities, no matter if you're a writer or if you are a designer or an SVG expert or anything, and and try to find a way you can apply that impact.
That was very well said. Thank you, Sean.
Mm-hmm.
I think we're ready for our next speaker. Thank you so much, Sean.
Oh yes.
A round of
Thank you.
applause, please.
Thank you.
So our next speaker, I've heard so much from talking to everyone about this speaker. Everyone's really looking forward to it. Like, she's one of the best. And she's going to be talking to us about the impacts and consequences that we have on the technologies that we help shape on our lives and other people's lives, and how we can be a positive influence on that change.
Yeah, Sarah's very accomplished, an award-winning speaker, writer, author, staff writer at CSS Tricks, senior cloud developer advocate at Microsoft. And I don't feel I need to list any more accomplishments because it's like a long list. So let's hear it from Sarah.
Thank you. All right, it's the last talk of the day. You guys made it. And, the first thing I want to do is to thank the MCs and the organizers for having such a great conference. So give them a round of applause. All right, now I'm going to ask something of you. Everyone in this room, I would appreciate it if you'd take your phones out and hold them in your hands. You can do it. Okay. Everybody, pretty much? Okay, now pass your phone to the person on your right. Okay, look at that phone, feel it, recognize it, but you almost can't do that, right? Because you're so distracted thinking about your phone in someone else's hands. Oh, it's awful. It's just awful. And the thing that I want to bring up here is that the reason that we feel this way is that our phones are now an extension of ourselves. These phones become who we are and our connection to that data. Pete Smart makes this point when he talks about designing for human-computer interaction, which we're going to talk about a little bit today when he talks about our relationship with technology. But we're going to talk about it with a different stint. We're not going to talk about the device itself, but how we relate to these technological advances. So you can pass the phones back now. All right. So there are a lot of different takes about living our lives increasingly online. And if you're in this room, chances are, as we started to adopt things digitally, you got excited. We were thinking about all the things that we could build, all the things that we could make, and curiosity for how we could represent ourselves online. So first we have GeoCities, which was like a bastion of internet explosion. I mean, I can't make something this good. Nobody can. Like that's just it. We reached the pinnacle right at the beginning. Then we had MySpace, which a lot of people customized. Everyone was friends with Tom. And actually, in putting this talk together, I revisited mine, which was a time capsule to terrible bangs, weird old art pictures, and weird pictures of me in a bathroom. I don't know. It was a phase. Some people might have started developing with Dragon Ball Z. And some people started because they wanted to be elite hackers, so good at programming that their fingers were literally on fire. Whatever our interests were, the internet allowed us to explore and share our lives and express ourselves in creative, bizarre, interesting, and unique ways that only a collectivity of humans could possibly imagine. But the only constant is change. And soon we had so many ways of being represented online and so many people were online that we needed to automate these tasks. We needed something that could analyze, build, manage, and sort for us. And as things become more complicated, what we realize is all of our lives become summations of these digital models. We become pieces of someone else's algorithms, which means we could be summarized in a single way. So people are starting to use search engines rather than libraries or teachers to make sense of the world we're inhabiting. These inaccuracies start to be reflected in what we learn, what we believe in. They become our societies and our education. And tech can be super magical in this way, right? That's such a cool thing that we can all be here together for the same reason in Iceland. But just like any other software we write, the more magic it contains, the more it can fail. I'm Sarah Drasner, known on Twitter as Sarah Edo, and I work for Microsoft. And today's talk is called Live and Machine Learn. So in this talk, we're going to explore the paradigm shift that machine learning brings, and we're going to do that through talking about how machine learning works at a really high level. We don't have a ton of time to go into it. But we're also going to talk about challenges to democracy through machine learning. We're also going to talk about machine learning for good. Machine learning does a lot of really cool things, and we're going to talk about those too. And then we're also going to talk about some of the practical tech that we all know, so not necessarily machine learning, but how we can make a difference with some of the things that we know today. So let's talk on a very high level about what machine learning is, and we'll kick it off with a quote by the fella who coined the term. Machine learning gives computers the ability to learn without being explicitly programmed. Okay, so we're programmers. We're familiar with if-then statements. So what if these conditions for the if-then statements become complex? I mean really complex. If you're building a program to understand that this is a pug and this is a kitten, you don't necessarily want to program an if statement for every single pixel here, or the possibility for every pixel for every single pug photo. I mean, that's not how our brains work, right? So how do you program it? Well, you want to teach it a certain pugliness. You want your teacher to learn, you want your model to learn the essence of the pug. So in truth, there are a few ways of doing this. Sometimes, like the example above, we can tag a set of data, and your model will use this supervised data set to distinguish between these classes. And this will help it learn better. This is called supervised machine learning. But there are other times where we don't really know the answer. So if I asked a computer what those pugs would look like if they were bred together with stegosauruses, well, that's not really a thing. So there's nothing we can check against, and that's when we'll use an unsupervised process. But let's dive into supervised process because it's the easiest to explain in the time we have, and it's also pretty common. And in truth, even within supervised machine learning, there are thousands of algorithms that you could use. And among those, convolutional neural networks are probably the most popular, but genetic is the easiest to understand. So we're going to use that to kind of discuss things on a high level today. So let's explore a simple toy model. In order to make a pug-kitten sorter, what we do is build an algorithm that builds algorithms. It will build many of these, and they'll do their best to sort these and do their best sorting. And at first, they'll be bad at it. They won't just be bad at it, they'll be terrible. But we have another function that will check this, and they'll check it against that tag data, and for every kitten and pug scenario. So the ones that get it wrong are thrown away, and the ones that get it right circle back to the builder, and then the builder starts using those to create new builders. Now, this might seem hacky and imperfect, and that's because it is. If we did this once, twice, or 3 times, it would fail, but we do it thousands of times. And we don't do it for a small amount of conditions either. We build up all of the gradients that make up an eye, and then we match it up against all of the other eyes that we know of. And then we match that against the likelihood of snouts.
And in fact, our own classification system, genus, kingdom, phylum, is a really human comprehensible version composed of this kind of set of rules. So the part I want you to remember is this moving forward. The point where we check, you can see how that's a very important part of this. We have to check if we want to get the data right, and we must do so and keep on checking. And another really important part here is, if I only gave these pug pictures that it was fed on, I mean, that would be correct, right? These are all pugs. But what might happen is it might fail when it's trying to find our one true pug. So the type of data that we train on is really vital to whether or not we have an accurate model. Okay, so let's explore some ways that machine learning has failed, but I'm going to call this section "The Road to Hell is Paved with Good Intentions," because none of what I'm showing you here today is made with the idea of corrupting society. Quite the opposite. All of these are really well-intentioned examples, but their failure is really good for us to explore so that we don't fail in the future. So let's say you need to patrol a city, but you don't have enough patrol units to completely cover the city. So it might make sense to figure out where all the crime is happening and just have some patrol units that focus on the areas of most activity. But the problem is, not all crime is equal. To get enough data, you have to include nuisance crimes in which no one's hurt, like homelessness or panhandling, with the violent crimes like rape and murder. But rape and murder don't tend to be clustered in this way. It takes a lot more data to build an area, which is why the nuisance data is included. So another issue is that those nuisance data areas, those tend to be the poorer areas. So what ends up happening is you get more patrol areas in the poorer areas, and then we have more data on those patrol areas, and we get into this weird feedback loop where we're just patrolling those, and then the rapes and murders that happen in the affluent areas start to not be reported. And this is what the software Predpol does that we use in the United States, and it's an example of sample bias in machine learning. So another issue with this that the US Department of Education has found is that once you're a criminal, once you're a criminal, you're pretty likely to become a criminal again. A lot of people keep reoffending, and what they found was the reason why people do this is that they report that they find it really hard to fit back into society once they're in jail. Another thing is that employment becomes more difficult because you have to disclose that you were once in jail on your employment forms, and then people are less likely to employ you. But here's an important part. Employment tends to be the #1 indicator of whether you're going to end up back in prison. And even the analysis of who ends up in the system uses machine learning. So when most defendants are booked in jail, they respond to a COMPAS questionnaire. And this is fed into a system that defines the risk level that's used in the length of their sentencing. So whether you're in for a short amount of time or a long amount of time. And an evaluation of more than 10,000 of these people found that the risk scores showed a startling difference. Black defendants had scores pretty evenly matched across the board, 1 meaning no risk, 10 would have a very long sentence, whereas the white risk assessments look quite different. Many are assessed at 1, steadily decreasing to very few at 10. Now, you might say, well, what if that's just valid data? Except upon analysis, it's not really. The study showed that blacks were twice as likely to be labeled higher risk and not reoffend, while their white counterparts were labeled not as risky as they were. So if we look at this in human terms, we see James Ravelli with low risk at 3, Robert Cannon with medium risk at 6. James Ravelli had a domestic violence, aggravated assault, grand theft, petty theft, drug trafficking, and he subsequently did reoffend. Robert Cannon had 1 petty theft. There are more, too. Gregory Lugo, low risk at 1. Mallory Williams, medium risk at 6. Gregory Lugo had 3 DUIs, 1 battery, and subsequently reoffended. Mallory Williams had 2 misdemeanors and never reoffended again. And these are just a couple of them. There's a lot. These kind of algorithms don't just affect black people either. Zilli is a construction worker who stole a piece of equipment and sold it for parts because he was low on cash. Since then, he's been going to church, he's been volunteering, but he says that his risk score doesn't reflect any of the ways that he's bettering himself as a person, therefore not really a good indicator of whether or not he's going to reoffend again. So what makes COMPAS fail as a machine learning algorithm? One thing is that it has no transparency. You basically make the algorithm and then they are sending it out. So basically, the people who are using it don't know how it works. Another thing is because of that relationship, it doesn't adapt over time. Remember, we talked about how important that step of adapting is. And related to these things, people use it without any questions. Another question that might be asked at this time is whether this is a good place for machine learning algorithms. Machine learning algorithms are super powerful and really wonderful, but sometimes this should be in the hands of a judge. And here's the main thing about machine learning algorithms. We try to be predictive of the future, but machine learning algorithms can really only evaluate the past. So Brennan, one of the co-creators of this technology, didn't actually build the technology with the idea of the use for sentencing. But that's the strange thing about some of this tech. Once you put it out in the world, adoption can be beyond us. Anyone who maintains an open source project will say that sometimes you put something out in the world and the way people use it is totally different than the way that you intended or the way that you had foreseen. This is why it's critical for these types of technologies to be transparent in order to not be abused. They can't be magical. People will say algorithms can't be biased, but algorithms are written by people. So this doesn't always happen to only happen to criminals, it happens to us too. Machine learning is now incorporated into a lot of the tools that we use every day, and a lot of our internet experience is built off of machine learning algorithms. So Axiom, a data brokerage, had an average of 1,500 data points for 500 million consumers, including the entire adult population of the United States. That was in 2012. And that's just one company. So using a Chrome extension called What Facebook Thinks You Like, I could find some of the ways that the systems had tagged me. So some of these are pretty obvious. If you follow me on Twitter, you probably know some of these things, like software developer, I'm into cloud computing, I like dogs, I like wine, to strange and like kind of false. So mermaid, I don't know, trench coats, I've never read a James Patterson book, I don't knit, and it even got my political proclivities wrong. So the issue with this is Facebook uses these types of tags to drive directed ads. And you can see that you can use these ads to target on different demographics, including race. And a couple years ago, people could show you different houses that you could buy depending on these demographics, depending on race. This is illegal under the Fair Housing Act of 1968. But here's the thing. Once that was pointed out to Facebook, they fixed it. And this is a major theme here. It's not to make software that never fails. That's impossible. Every machine learning algorithm can have a failure. But once it does fail, you have to course correct and change things. And another problem with this that you might have already thought about is that you don't tell Facebook your race. They're targeting based on ethnic affinity, which is used by the same algorithm that thinks I'm into mermaids. So I'm not coming down on Facebook in particular. This is a problem with all machine learning algorithms used by every company. So the issue with this, and what you might have guessed, is that everything that you're seeing is filtered. And that filtration system can be fallible at best and illegal at worst. It might not mean houses. It can also mean that the things and the studies that you're seeing and the educational material that you're seeing is based on what you already believe, which, like that patrolling system that we saw earlier, becomes a self-reinforcing prophecy. And I've also personally seen this. At one point I worked for a company that was starting to use machine learning. They proposed an idea to surface content based on demographics. I had just happened to read up on that issue that weekend, mainly that it wasn't legal, and I brought it up to people and they said, oh yeah, you're right, this could probably introduce bias, so we didn't ship that feature. But here's an important part. I was just a regular engineer on that project. I wasn't a data scientist and I wasn't a PM. I wasn't the person shaping that project. I was just carrying things out. But without raising my hand, we might have shipped that feature to some really bad consequences. It's not that digitizing the world is inherently bad, but the more technology becomes embedded in all aspects of life, it matters whether the technology is biased, alienating, or harmful. And these tales are pretty dark, but machine learning offers us a lot of amazing benefits as well. As my brilliant coworker Paige Bailey says, it's like the risk that we take every time we get into cars or airplanes. They've completely transformed every aspect of life and made things possible that wouldn't be possible before. They're inherently dangerous, and they can be seriously misused. So think about it. I mean, I wouldn't be on this stage if it wasn't for airplanes, and some of you wouldn't be here, right? All in the same room. That's pretty amazing. But people have used airplanes as weapons, and so we have a certain respect for them. Okay, now that I've bummed everyone out, let's explore some of the wonderful applications for machine learning and what we can do with it. Okay, as I mentioned, I work for Microsoft, and in Azure we have a thing called cognitive services. There's a specific API called the Emotion API, and what it allows us to do is analyze things like pictures and videos and see what emotion it detects from what the computer sees. It can be used to make things like this, which I built in 3.js, which has no practical application except entertaining my 4-year-old stepdaughter.
Wow.
Wow.
I got cute.
Yeah, there's stuff up there, huh? Okay.
Which can also be pretty magical, to tell you the truth. But what if we put this to more useful use? Okay, so I was mentoring a blind woman, and she mentioned to me that she felt left out of a lot of conversations on Twitter because a lot of the photos didn't have alt text. And this is true for her even on things like news sites. So I used another cognitive services offering, the Computer Vision API, which will not only analyze photo, but also its contents like words. And just to show how some of this works, we're going to dive briefly into some of the code. So we'll get the image from the user. I'm using Vue.js here. These are methods, and we're going to store it. Then you can see here we're using Axios for a simple call to the Computer Vision API, and then we're going to use Azure's cognitive services to analyze that image. And we'll do so in a couple of different ways. One to see what the image contains, and one to check for text within the image. Then we'll dynamically add the alt text to the image. And now that this is built, I'm building a Chrome extension so that blind people can use it on any website that they can visit. So this application of machine learning can help bring more people into the conversation and broaden our reach. It's not perfect, but it's headed in a really good direction, where all of a sudden people who are left out of the story can now be part of it. And that's the amazing thing, that by being inclusive, you're actually meeting business goals. It doesn't mean you're excluding the people in the center. It means that you're reaching a larger audience. There are all sorts of ways that other people can use machine learning in medicine, too. So one of these is Sophia Genetics is training algorithms to diagnose diseases through DNA analysis. Another one that's kind of dear to my heart is that All4Cure is a social network for cancer patients where patients can enter diagnosis and treatment so that it can be analyzed. This is really important because doctors can't just report every single patient that they have, and they can't read every single study either. So if you have all of these people reporting what treatments they were used, whether or not they're surviving well, then all of a sudden this machine learning can pick up all of that data, and we can become much smarter in finding cures for cancer. HealthMap algorithm spotted an Ebola outbreak 9 days before the World Health Organization. And this is a really important one, so I'm just going to focus on it for just a second. 9 days is an incredible amount of lead time on an outbreak. Outbreaks grow exponentially. So by using machine learning, we adjusted the amount of people infected from here to here. That's amazing. So you might be saying to yourself, this is all well and good, but I'm not a data scientist and I don't work with machine learning. But that's okay. This subject about how technology can shape our lives is really broad, and it doesn't necessarily have to be machine learning. So let's talk about some of the things that we as web developers can do now today with what we already know. We work every day on building applications for so many different use cases. So what if we take some of the more generic tools that we have and put them to tasks where we can maybe help save lives? So there's a firehouse near where I live, and they have some sufficiently complex systems to make sure that everything is online and functioning. I went out to their station and I asked them a few questions about how everything works and to see if there was anything that I could do that might help. And here's what I learned. When the truck goes out, it has to communicate with a dispatcher, which will help facilitate if they need more water, supplies, or backup. And the app is really simple, kind of purposefully so, because they want everybody to be able to use it quickly at a glance, and there aren't that many things that they might need. So for their use case, what they created is really perfect. But I asked a few questions, including, what happens if they're all of a sudden offline? What if they can't communicate? Well, right now, they're hosed. Get it? Hosed, fireman? Okay. Anyway, terrible joke. Okay, so here's our opportunity. What I created was a really simplified version of their app, preserving the basic layout, but I made use of service workers and background sync to alert them when they're offline. When they're offline, queue the messages, and when it's back up, send them out, even if the browser tab is closed, even if something happens. So here's what the application looks like. If we click on water, the sync is registered and it sends it out. But if we go off Wi-Fi, then it'll tell them that they're offline, and then I could even close out that browser tab, go back, and then we can turn the Wi-Fi back on. And then the sync is registered, and what we requested before is then sent out. So the first thing that we're going to do is alert them when they're offline. We're going to do that with navigator.online. And we're going to register the service worker when a request is made. The service worker isn't just a normal function. You can't just add it as a method in your app. It has to be in a different JavaScript file, and this detail is really important if you want to integrate it. So one thing about this is that you're kind of throwing it over the wall. It's almost like communicating with a server. So you're throwing things at it, and it's throwing things back. So we're going to pass in the type of event that was triggered so we can submit or queue what the user requested. Not shown here, we'll do some error handling. And then after we've activated and installed the service worker, we're going to strip out the type from the event tag and pass it into a function that will process a fetch request when it gets connectivity. In that function, we'll fetch our URL, which is a placeholder server in this case, and we'll check if the response has happened. And once it has, we'll send a message back to the client with post message. So we'll send the response and the type of resource that was requested. And after that, we can alert the user when it's finally sent. But the most important part of the demo isn't the service workers. It's where we started. We started by asking questions. I went to the firehouse and I asked them questions. And there are a lot of times where I wasn't even sure if I could really help them. But by asking questions about what happened in any kind of use case and any kind of scenario, I finally found something that they could use the help for. We have to ask questions. We have to ask questions in the beginning, like the firehouse demo, and we have to ask questions like when it's deployed, like the criminal scores. We have to keep evaluating these systems and where they're going and make purposeful decisions to help people and course correct when we don't. I see a lot of tech that asks questions about how we can make our lives more comfortable, which I appreciate. I make apps on the weekends. This is a cocktail finder I built that just finds me cocktails, okay? But it seems to me that a disproportionate amount of projects focus inward rather than outward, focus on serving people with money instead of asking people if they need help. There are a lot of opportunities out there to help, and you might already have the skills to do so. It just takes a little bit of imagination and exploration, and it can really pay off. So what I want you to think about going forward is this, that I truly believe that you're some of the brightest minds of our generation. As you move forward building applications for the web, you're building the pillars and blocks that our society rests on. You're crafting the shape of our digital lives. This could mean building new features, this could mean advocating for accessibility, and this could be as simple as raising your hand when you think something isn't right. It's not just your job to create these things and do as you're told, it's also your job to ask, are we building things correctly? Are we building the right things? And are we building them well for all of the digital lives that we touch? Thank you.
Thank you so much for that. I learned so much. I know that majority of the time when we're working on some, tool, product, tools, whatever, we can't really tell whether it's leaning towards the more evil side of things sometimes. What are questions that we can ask ourselves and also our teammates to kind of, be able to know like whether what we're doing is ethical?
Yeah, I mean, I think just asking the question is the first step. For a lot of these things, like what I mentioned before, is like not saying like you're going to build software the first time that never fails. That's never going to happen. But just kind of reevaluating these systems as you're building them, or kind of asking the questions like, even if the answer is no, it's probably fine, but just asking those questions up front about where things are going and what you're building.
Yeah, thank you so much. And that was our last talk. Oh my God. Can't believe it's almost over.
You found your suit.
I did find my suit.
Where
So
was it?
I think they saw that Sean told me that I can tweet him and he would help me. And so I guess they're like, oh, I guess I can help her, make faster applications. So I'm like, oh, well, I'm good now. But yeah.
That made total sense.
Anyway, so we have our panel coming up, and we're going to be talking up here on stage and answering some of your questions that you're asked, some of the panelists. It's still up online, so if you go to slido.com and then enter JSConf as the event code, you can still ask questions. You can still vote on questions that you care about that we can ask some of the speakers on stage.
Yeah. So I think, are we taking a break?
I think we're going to take a quick break.
5 minutes?
Yeah, to
5
set
minutes
up,
break?
5
To
minutes,
set up?
so that we can get people up here on
Don't
stage.
stray too far. Come back in 5 minutes.
Yes. You might.
A lion heart, a lion heart, a lion heart, a lion heart.
down, take it down to the ground with me. Don't you think you're high enough? Don't you think you're high enough? Don't you think you're high enough for the fall? We are going far away, we are going far away, we are going far away from Utah. Don't you look down, don't you look down, don't you look down, don't you look down. You are high above ground. We are driving with our friends. We are driving to a faraway place. We are driving with our friends. We are driving to a faraway place. We are driving with our friends. We are driving to a faraway place.
Time to give up bad habits I find, taking over everything, including my mind. Living with confusing writings on my wall makes it hard for me to walk out the door. It's time to attend to the pieces of my heart I routinely tucked away for the most part. But like an ocean that rushes to the shore, I can't hide my emotions anymore. So I roll gently down the stream until I'm finally home. It's time to change and time to make amends. I'll try even though it makes no sense. Giving up is not an option anymore, so I'm floating to where I belong. And I'll roll gently down the stream, build up a steady pace to where I need to be. And I'll roll gently down the stream until I'm finally home. It's time to get up and head out on the lake. The sun is shining and I need to make use of it. Thank goodness it's been raining all summer long, so I'll find me something good to float on. And roll gently down the stream, build up a steady pace to where I need to be. And I'll roll gently down the stream until I'm finally home. I'll roll gently down the stream
don't have to change me. I've already set my eyes on something. Oh yeah. I really wouldn't blame you if you walk down out the door because of me. Yeah. Come on, baby, let's forget about the truth. Try to set my mind on something. Oh yeah. Don't try to chase me. Don't try to chase me now. Come on, baby, let's forget about the truth. Try to set my mind on something. Oh yeah. Don't try to chase me. Don't try to chase me now. Yeah. I wanna do the right thing. Oh, the pretty girls like Samuel. Oh, it really doesn't share. Though it's more than he can handle. Life is anything to fair. Life is anything to fair. Oh, 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 oh. Woo-hoo-hoo. Oh, oh, oh. Just as soon as they turn over, come and sweep them off their feet. It's only making me feel smaller. Oh, the hidden love in me. So won't you lay me? Or won't you lay me down? Won't you lay me? Or won't you lay me down? Won't you lay me? Or won't you lay me down? Won't you lay me? Won't you lay me down? All alone, alone again. No one lends a helping hand. I have waited, I have waited. It takes a toll, my foolish pride, long before I see the light. I have waited, I have waited for you to lay me down. Sail on by for now. They play naked in the water. You know it's hard, heaven knows I've tried, but it just keeps getting harder. So won't you lay me? Won't you lay me down? Won't you lay me? Won't you lay me down? Won't you lay me? Won't you lay me down? Won't you lay me? Won't you lay? Oh, won't you lay? Varje alltid flere stunder, flere minutter, flere år, flere netter, flere steg. Så I vil give me Italian.
Instead of your diaphragm? That was very sudden. Anyway, we're having a conversation about breathing. Because, you know, we're human and we breathe. So it's just a very common thing to talk about.
Hi. Saying hi. Sound polite.
Anyway, should we introduce...
Who are these people? It's not like I've ever seen them, ever.
Yeah, it's not like they were, I don't know, people who talk and they're, you know, famous on Twitter, has like 10 times more followers than we both do combined. I don't know.
So if you don't mind, I guess do a quick self-introduction again, please.
Do we need to pass the mic?
Yeah, the mic is ready, yeah.
Hi, I'm Dan. I work at Facebook on the React team.
Hi, I'm Sarah. I'm a senior cloud developer advocate for Microsoft.
Hey, I'm Sean Larkin. I'm a program manager at Microsoft and maintainer of Webpack.
And hi, I'm Anna Henningsen. I'm a student and I work on Node itself.
Cool. So yeah, we opened up Slido and we were accepting audience questions. So yeah, I'm just gonna go down this list. First question is, apparently this is like a tradition in Iceland. It's a question that all Icelandic people have to ask foreigners. I don't know why. You can ask them back why. How do you like Iceland? That's the question. Yeah.
I mean, I love it. I've been asking to come here for a very long time. So I'm really excited to be here. And I just think that Iceland is super beautiful. So I can't wait to explore a bit this next week.
I haven't seen much of Iceland yet because I just gave my talk and then I slept all the day and I slept until 2 p.m. today. I'm going to watch the talk that I missed later. So I'm looking forward to actually seeing Iceland tomorrow.
So like for me, Iceland actually feels quite a bit like home because like I grew up pretty close to the North Sea, pretty close to Scandinavian countries. Yeah, it's nice being here.
Iceland's awesome. You know, like, so like I'm typically allergic to beer, or at least American beer, and it's a long story. We think it's the yeast, but I can drink Icelandic beer no problem, and so that's one more European country that I can really enjoy their great beer. So.
Great. I hope all the locals are satisfied now. Moving on.
Yeah, so our next question is, you are all high-performing people. What tips do you have for being productive?
I'm sorry, I really don't know.
You can pass, it's okay.
I'll pass it.
Well, okay, there's a trick that I've been doing recently, which is I have a few different to-do lists, and I have like the to-do list for the day, and there are things that are kind of lower-hanging fruit that I can get done really fast, and then things that are longer term, and those I break up into actionable things and put on my daily to-do list, and then I have like a big, long-standing to-do list that is never going to be done, and I'm fighting interview constantly. But one thing that really helps is if I envision a bunch of the tasks complete, I get this like dopamine rush of happiness. And then I'm like, okay, chase that excitement and go try to do that. So that helps.
Sounds like you're doing David Allen GTD, like with the lists and the next actionable item. Yes, so like that's something I just subscribed to or prescribed to. Yeah, like when you have something you need to accomplish, just write down the next actionable thing that you can do. And so you constantly just whittle away at it until you've completed something. And then a lot of lists which like cross different matrices, like the list when I'm at home, or the list when I'm like in my email, like, or the list when I'm on Twitter doing DMs. But then also I would say there's another part of that GTD method, which is like do, defer, or delegate. So like if it's not your top priority, or I mean if you can do it in less than 2 minutes, just do it. If you can't, defer it till when it's appropriate, and if like whether people like to hear if it's not worth your time, then delegate it to somebody else who's better suited for it. And otherwise, like ask people for help. So like people are like, Sean, how do you do things all the time? I say, I can't. I'm usually drowning, and people pull me up and help. And so like, well, you know, we really rely on other people around us in our community to help us get things done for Webpack.
I'm not sure like I have a great answer to this question. It's just like, so like I have something that drives me, and that is just like trying to understand things, trying to like build things that like fit together really nicely. And just like I care a lot about what I do, and I mean that sounds very, very generic, but it's true, and like that's why I can keep doing Node for such a long time. I've never worked on a project for like more than a year or anything, and just like, yeah.
Yeah, I just wanted to add, I had some time to think about this now, and I just wanted to add that I second the suggestion to ask people for help. So like, for example, the demos for my talk, I had a lot of help from different people who helped me do the actual design work on them. So if you look at my Twitter, I posted the way these demos looked before I had the design help, and they didn't look quite as good. And the other thing that, in terms of like task management, what I usually do is I have a Trello board with like things that I want to do, but I just use it to stop being anxious over these things. So I just write them down, but I never actually use that board. So I just put them there so I don't have to think about them. But in terms of like daily work, I try to have just one to do like for a week. So I just think about one particular thing that I want to finish, and so I don't have to constantly consult the to-do list.
I find that with having multiple to-do lists, I mean, I try to do this myself, but there's, I guess, a fine line between like being productive and also getting really overwhelmed by the amount of stuff that you're doing. Sometimes, you know, it gets lost in like emails and lists and, you know, notes and all that. Is there a way that you deal with this in the systems that you do?
I'm bad at email.
So like, I mean, like my system for keeping track of stuff is basically having a huge GitHub inbox in my mail account, and just like not being scared to just like from time to time declare bankruptcy and just like set everything to read. And, works pretty well because like, I mean like usually like if there's something where really something bad happens, if I don't take care of it, like I usually notice that, and if not, somebody like pings me about that.
Yeah, getting to inbox 0 is like, feels really good. So like I try and like, if there's no actionable like details, I just boom, archive it. So I never have to see it again, but if I need to search for it, then you instantly at a glance can like, at most, like by the end of like my workday, I'll only let like 2 or 3 emails sit there. But even then, like I try and archive them anyways. So I have tasks created for them, but yeah.
Awesome. So the next question, what do you see that needs fixing? I'm guessing the question means like, what are some common problems you see in JavaScript applications that don't currently have a good solution to?
Well, this is not exactly the answer to this question, but I give a lot of workshops and I work alongside people a lot. And it's not a problem with JavaScript, but one thing that I've noticed when people are debugging, that they tend to not be very methodical, and that usually is the thing that changes between whether you're going to solve the problem or not. And I guess that's part of why I'm bringing it up, is because it seems like you're going slower because you're doing things one thing at a time or something, but you know that what you can kind of validate that what you did changed the thing, instead of doing 5 things and you're not sure which thing actually changed it or fixed it. So I'm just bringing that up because I think that that can lead to a lot of problems in JavaScript applications and bugs.
I think that's a very interesting observation. I also kind of noticed this, and just as I spend more time writing applications, I noticed that I become more methodical in like debugging and designing. And I think that maybe there is a certain lack of education around not specific, like using specific libraries or specific APIs, but more about how to think about an application, how to think about like debugging problems, splicing them like in half to test if certain hypothesis is true, and how to do a little of upfront design work. So if you're creating educational content, this might be a good opportunity.
You can go. Oh. I think maybe one specific, in the same realm as what kind of Dan described, is also kind of understanding what things you use, and like having a that same methodology around understanding the code you actually leverage. So like if you're using a library or a component or something that's from NPM, I think education around how to identify like what type of module this is, and how, like, I guess you could say a package health, or just understanding those details and how you go about seeing like, oh, is this contributed often? Is this written in ESM? What libraries does this depend on, or does this have other dependencies? Things that you may not really think about when you're just trying to write something or add a feature, but could have a long-standing impact if you pull in the wrong library versus another.
I'm also just going to plug my thing again, but I think it's really hard to write asynchronous code that works correctly.
Yeah,
so
that's true.
I'm hoping that some of the features that I showed in the demo will help us with that.
I think that actually leads quite good to the next question. So we have pretty generic questions, but this one's a little bit more specific. It's specifically for Dan. Sorry. Will the future API you demonstrated work with server-side rendering?
So we don't currently have an implementation for server-side rendering. In theory, yes, we have ideas about how to make this work, but we'll probably need some help from the community for actually implementing that. So we're going to post some details later, and hopefully we'll find people who can help us.
Awesome. So the next question that I want to ask might be controversial, but what is your unpopular opinion about front-end dev?
Unpopular opinion?
Yeah.
Yeah, that's not hard. My unpopular opinion is that it's not complex to ship fast websites. It just takes a little bit of process and treating performance like a first-class citizen. And so, of course, it's going to be difficult to try and tackle on an existing project, but I always heavily evangelize trying to make things like performance and how much JavaScript you're shipping or how much CSS you're shipping as just part of the culture of that project and a first-class citizen. If you treat it as something you come back to, unless you're using the right technologies, you're almost always just going to be trying to dig yourself out of a hole. And then you're just sacrificing time. So if you just treat it as a feature that is a standard for anything that you write, then it is easy. So I mean, I know boiling it down into easy is kind of hard, but if you understand the concepts, and you can ask me anytime, and I'm happy to spend as long as possible explaining those. But yeah.
So like, okay, an unpopular opinion I have. I don't like CSS and JS as a concept. Um, I mean, like, I haven't like done a lot of front-end dev in a while, and like, I learned front-end coding like 10 years ago. So might just be me, but like, I still think separation of concerns is kind of a nice idea. Like, maybe it's not all bad.
I have two unpopular opinions.
The more the better.
The first unpopular opinion is that we don't all have to build things the same way. I think a lot of people are like, everybody over in here in this camp, or like, everybody's got to do it this way. And I just think that that's crazy because we all have different sized teams and different use cases, and we're building for different audiences for different reasons. And I just think that the web is a really big tent, and we all need to be a little bit more flexible in our thinking, and that would probably cut down on some internet arguments. But those are fun too. My second unpopular opinion, which is probably everyone's going to be like, yeah, sure, of course you're going to say that, is that SVG is awesome and underutilized for the web, especially especially for performance benefits. You can take, I mean, I've worked on some consulting contracts where, you know, I took their load time from 10 seconds down to like under 1 second just by optimizing the graphics and changing things over to SVG and optimizing things correctly. So like, use SVG and learn it. Okay.
I don't know if that's, like, when people ask for unpopular, I'll say on Twitter, here is my unpopular opinion, and often it's not really unpopular, so I don't know if this one is going to be it, but I think there is a lot of focus in the community on synthetic benchmarks, and like, you know, like this table that shows a comparison of different implementations with a very synthetic kind of load that doesn't really describe what an actual application looks like. And I think that as a community, we should create better benchmarks and focus more on real-world scenarios, and consider then that if you optimize it, you can optimize a tiny slice of your application time forever and like make it 2 times more performant. But if the actual problem is in all the layers that you have, that tiny slice you're optimizing doesn't actually affect like the real application time. So we need to be we need to have we need to apply optimizations on the whole programs and whole on all layers, and not just one tiny layer.
I feel like Dan's unpopular opinions slowly turn into popular opinions. He just has that energy that just makes it to a popular opinion. So I feel like.
Then I changed my mind.
Okay. No, I'm not talking to you, Google. All right. So, what is, for each of you, your single absolute most, what are you most excited about in the JavaScript ecosystem?
I'm going to scoot over here and say Vue.js is really cool. I'm just kidding. I just said that everybody doesn't have to build the same way, so obviously that's a joke. I hope you know that that's a joke.
I think React is not bad.
Like the single most exciting thing?
Is it Webpack?
It's not Webpack. The single most exciting thing is for Node 6 to not be supported anymore. So like that will be really exciting to me, because then we can use WebAssembly in Node without, you know, like you can just use it. And so like so many different features become available that, and so much different type of computing can be done on Node that is in that, you know, we kind of have to treat Node 6 right now as a second-class citizen if we were to pull it into, you know, our library. So WebAssembly in just as a whole is, man, it's going to be crazy.
I'm not going to go with Node. It's actually the NPM registry, because like no other language has anything like that, not remotely. It's just like it's it's so incredibly easy to just like make your own stuff public. And that's, yeah, unparalleled, I think.
Next question. Ooh, so many questions for Dan.
Yeah, crowd favorite.
He's an audience favorite. Let's see. Ooh.
Do like a generic one, like not, yeah.
Ooh, I found something that it's not too upvoted, but I actually like the question.
Go for it.
It says, it's from Luke. Can you identify a moment in your career that made you feel most joyful? I feel like we always think about the worst things that happen, especially in our career, like our build's breaking, production's down, and all that. So I feel like this is a good change of pace.
Yeah. So I was converting. I was working on a web app, and I was converting it from Require.js to Webpack in 2014, I think it was. And I found a page called Hot Motor Replacement on Webpack Docs. That was the old Webpack Docs where like you couldn't really. It just described the API functions, and none of it really made sense to me. So I asked on Stack Overflow, what is that exactly? And Webpack's author, Tobias, he replied me with like a really good explanation. And so I was thinking, wow, I could combine that with React, because it's like React is declarative, and so I could maybe have it update, edit my components and see changes in real time. And I was so fascinated by this, and like I thought, okay, maybe I can make a prototype of this. And I think I stayed until like 6 a.m. And finally, at 6 a.m., it was kind of working enough for me to record a video of it. And I posted the video to Twitter, and I had maybe like 50 followers at the time who were my friends. And Christopher Shadow retweeted that video, and it felt good.
Okay, so I feel like this is going to be a weird one. But like it was actually, like what I'm thinking about right now might have been more joyful moments, but it's in my mind. It's like when I actually like pretty much completely understood what actually was happening when a Linux kernel executes a program. It's like every step from just like the exec call to the actual main function of whatever program is supposed to run. There's like so much going on, and just like it's pretty amazing to look at and to understand.
I think for me, the most like exciting time in my career was like the first time I ever got to go to a conference was the first time I ever spoke at a conference. And so it was NGConf. And so I don't even remember if I did really well or not, but like the feeling of having people clap for you and actually understand how a technology works and kind of the sparkle in their eye it feels so good, and it's just unsatiably addicting. And so it may happen more times, but I remember that one the most because it was the first time I could experience that feeling, and kind of what it meant to be able to empower or kind of have other people be passionate about the same things that you love.
I actually think that probably the most significant moments for me have been very quiet. Like they haven't really been like a moment where, eureka happened, but just like me working for, 12 hours and forgetting to pee and eat and stuff and just like having a really great time, because I feel like when I'm in, that flow mode, that's probably when I'm the happiest. So no moments that are like recordable for something like this. So I would say like the one that comes to mind that was more like career enhancing was that I had been kind of quietly making a lot of work for a really long time, and nobody really knew who I was or anything. And then I spoke at this conference where I showed a ton of demos, and that kind of went and you can see like the analytics on my website went like this to like that, just like from that day, because people all of a sudden saw that work, and that was a really good feeling because I was like, finally, people are gonna like look at this stuff I've been making for forever. Yeah, I would say that was probably like the most career enhancing one, but the happiest ones have been quiet.
I think that was a good choice of question. It's like a feel-good one.
Yeah, no, I feel
like
good
it.
now.
Okay, the next question was originally specifically for Anna, but I think it could be made to be for everyone as well. So Anna, what's a good entry-level way to get involved with the Node project? But since everyone here is quite active with the open source, well, different open source projects, so I think generally, what's a good entry-level way to get involved with an open source project?
You can go first. You can guarding the mic. I can't wait to talk.
You can have my mic.
So like, for Node specifically, there's this awesome website. It's called nodetodo.org. It's run by Rich Strutt, which is like the best person ever to like work in a software project with me. And I'm just like so glad he's around Node, and he maintains a list of good first contributions for Node. And yeah, if you're interested in doing that, that's a really good starting point. I mean, like you can also like try to talk to me, and I'll find something for you. And yeah, you might want to like if you have something that you're especially interested in Node, that might be a good thing to do. Just like message me. Otherwise, go to nodetodo.org.
I would say like the first thing that you should do is figure out what drives you, like what gets you up out of bed every day if you want to contribute to something, and like take that skill and apply it to the project if it's applicable. I mean, most times it's going to be. When I started contributing to Webpack or even joined the core team, I had one commit to the project, and that's it. And I had 0 following on Twitter, so all I would do is go on Twitter and search Webpack. And I responded to every single tweet until, and that's it. Like, I literally did that because at the time, I had worked in technical support and I worked well with people. And so it's an easy way for me to provide value that's totally in my wheelhouse before speaking, before writing documentation, before doing any of it. So like usually some of the, like when people ask me this question, I usually end up like losing them to a different project like Babel or React or whatever, because they're like, well, I really like working on VDOM instead. But like I always say, understand what you love to work on, because that, I mean, to me is what open source is about, is that you are working on the things that really drive you and then making the world better because everybody else depends on it. And then also, to quote Dan Abramov from like who knows how long ago on Twitter, but when another advice is like, if a code seems intimidating, just start at the most familiar place and then branch out. I think that's like pseudo quote of you at least. Well, yeah, like start somewhere that you can understand and read, and then go further.
I still don't understand about like 50% of code in React. Yeah, I would say that, like, since I work in React team, I should probably say something about React. And I would say that maybe React itself is not the most easily accessible project to contribute to, just because there's, like, it's even hard for us to contribute to it, just because it's so, like, large and complex in terms of what it needs to do and how we need to think about all those features behaving well together. And we're trying to improve that with documentation, but it's pretty hard. But I think there is an ecosystem, and like the way I think one of the first contributions that I did before I was on the React team, I was just working on a project, like on a web app, and I needed routing, and I just started using React, and I saw this project called React Router, but the problem was that it didn't support, so when you switch between different pages, I think it would always scroll to the top, but I actually had an interface where I had tabs inside my app, and I didn't want them like switching tabs to scroll to the top. So I just sent a PR to implement this kind of behavior, and they've since removed that code and they made it work differently. But I think it's important that as you don't have to come to open source with the mindset of, oh, where can I start contributing? You can just instead build your own stuff that you need for your app, but have this mindset that this application code, it's not something that is like packaged and given to you and you can't tweak it. It's just code written by other people. It has hacks, it's not super fast, so maybe people didn't spend time optimizing it. It might lack important features. And if you come with this mindset of this code could as well have been written by me, then you can see, oh, here's how I can improve it. Here's the thing that I need for my app. And just try to add it. And it's often very small things that are actually very valuable. So maybe that helps.
Yeah, I mean, I think there are really good ideas in here. There's a couple of like small things, like a lot of GitHub repos have help wanted, good first issue labels. You could definitely explore those. There are other ways to contribute to, like speakers need people to practice with. If you know somebody else that's giving a first-time talk, or you can help mentor them in that way, or you can mentor people doing pair programming. Like, it doesn't necessarily have to be your first commit or something like that. But if you're interested in doing first commit, I think reading through the issues and getting a sense of where things are most valuable, reading before committing is really helpful, because then you kind of can see like what's going on in the whole project, what people are mostly focusing on, what people are mostly having a hard time. So taking some information in before adding things. And I guess the last thing I would say is, don't have your first commit be huge. Like, it's really hard to get a commit in that's gigantic, because maybe you have a piece of it that's really great, and then some other part is just like they can't use it, and then you've got to like have a million comments back and forth on your PR. So the first time you commit something, maybe just pick a small thing that you can work on that's much more likely to get in.
I also just realized that another very helpful, as Sarah put it, you don't have to necessarily like make commits your first contribution. I think what a lot of projects really need, and that includes React, is just somebody helping people out in issues. And for example, so when I started working with JavaScript, I have a Stack Overflow profile. So the first things that I tried to do was I was just reading questions that people would post, and I tried to answer them, even though I don't really know the thing. So I would research that question for them and try to figure it out. And if I have a solution, I would post it. And that really helped my learning. And I think you can do the same with any project you care about. You can just go to the issue section, see somebody posted the bug, try to reproduce it, try to figure out why it happens, debug, maybe suggest here's maybe you use this thing wrong, or maybe there is an actual bug and you can add more details for somebody from the team to actually help fix that bug.
One more weird anecdote story off of that, which is really cool. There's a guy who works with me on Vue Core who is like Linus Borg on GitHub and Thurston in real life. And he actually isn't a programmer for everyday life. He does a completely different job, and he's got like a hobby of contributing to open source. And he's like on the Vue Core team. And the way he started was he just went through and he read a bunch of Vue the Vue code, and then started answering forum questions. And he did that for a really long time until we were like, why aren't you on the core team? And he's built libraries and things like that. But I just think that that's such a great example, and hopefully someday he's on the stage telling his story, because I just think that that's such a cool thing that you can kind of start off answering questions and then eventually know the system so well that you're a core contributor.
Yeah, a lot of really good ideas there. I hope to see more people after this conference go home. Well, not tonight, because we have a party tonight. Go home and make at least one contribution to one open source project. That would be great.
I think we should wrap it up. Yeah. Any last words of advice?
If I'm allowed to criticize GitHub a little bit, I think it would be great if, so one of the reasons people contribute to open source projects is selfish, which is fine. So people want to show up as contributors and like have that in their profile. But I don't think, as far as I know, even if you spend like 2 years responding to issues and helping people, you still don't show up as a contributor on that project. So I think if GitHub could change that, that would be really great.
Also, if GitHub, if you're listening,
we have at least 2 GitHub
I
employees
would
here.
really
so.
love like a pay to support button, like an Open Collective for Webpack and things like that are super awesome, and I really like supporting things that way. I do support Webpack and other projects, but I would really love to be able to just like, you know, buy someone a coffee or like do something really quick to help support people. So if you're listening, that would be really awesome.
Nadia Eggball's on their product team now.
Oh, really?
Yes.
Oh, cool.
So she wrote a white paper about open source funding, and that's how she ended up at GitHub. So it was very nice for me to hear that she's on their product team now, and that could be a thing in the future. So.
Hi.
Are you listening, Nadia? Yeah. Final remarks. I would say, you know, I said it in my talk, and like, I'm really trying to destroy the idea of JavaScript fatigue. Like, I know that we all have everyday jobs and we need to get them done. But it's really important that we understand and embrace change, especially with JavaScript. This language changes so much. And so we do it at Microsoft. It's part of our growth mindset. Like, understanding and adapting to different changes makes you more dynamic as a programmer, or even just a human being in general. And we're not saying you have to use the latest technologies, but embrace what they are and take 5 minutes out of your day to understand what they are and what they do and what they accomplish. Look at the patterns and how they can be used in the things that you do every day. And that way, your everyday work doesn't feel frustrating. Embracing the JavaScript renaissance is fun, but you know, struggling with JavaScript fatigue, nobody wants to do that. So I think that it's just really important that you change the mindset. And so if I was to ask anything of you all, is to consider trying it. And you know, if it doesn't work, you can tell me I'm wrong on Twitter, and you know, show me this like screen capture or something like that of today. So yeah.
Okay, so I think I have 2 notes. One is something that I talked about early at this conference with Brian Hughes, actually. It's like if you think that some software product could do something better that you're using, like Node or Webpack or anything, and you find a way to work around that, that's cool. But like maybe file an issue or it, yeah, because like. I mean, like, if you're running into that problem, like 100 other people will, at least, and you have a chance to make their lives easier. So take that. And the other thing is, so like a lot of these questions that were aimed at us were like kind of like how to be successful in open source, or at least some of them were. And it's like one of the things that helps me a lot is just like doing completely different stuff. Like that has nothing to do with coding at all, just like because your brain needs that, and you can't work without that. Just like take a lot of time to do completely different stuff.
Awesome. Thank you so much to Dan, Sarah, Sean, and oh my God, it rhymes. Thank you so much to everyone in this panel. That was a great discussion. I mean, I'm sure that everyone here would love to ask even more questions, and it was, I mean, such a great discussion, hearing all those answers from you. I learned a lot personally from all of you combined, and
Don't cry, it's okay.
No, stop it. And also thank you to the organizer. I think we should wrap up and get to the closing, yeah.
Thank you.
Thank you so much. Yeah. Do we have the... Wait, is this still on? I don't know if it's still on.
And please don't leave yet. We still have the closing remarks.
Slow down. Can I show something? Okay. Okay. Can I show some slides?
Need my mic. Oh, I think it's working now. Hi. So we've come to the end of our 2-day event, and I mean, it's been super wonderful. Who enjoyed, you know, the whole thing? I just want to take my time to thank all the organizers for doing all of this. They've worked so hard. They work, you know, in behind the scenes. Everything is running so smoothly up here, but like, you know, sometimes they're dealing with so much stuff. So I just want to, you know, thank them and give them, you know, a round of applause because they've been so amazing. So yeah, we've come to the end, and it's, I mean, you know, really sad.
Sad face.
But we're not gonna let this get to us, because we're here for jokes. To those who can't see, it says, roses are red, violets are blue, unexpected bracket on line 32. To those who can see, this one says, yeah, I program in Java, please, I've been stuck at this enterprise job for the past 5 years. I'm slowly deteriorating. This isn't a meme, this is a legitimate call for help. Oh man, it's cut off. But this is another one. Anyway, we've really enjoyed Iceland. What do you think of it?
Oh, it's been wonderful.
We've-
Best time ever.
I feel like Jon Snow in that one.
Yeah.
It was really fun to whoever made that photo booth. It was really good.
The helmets were way too big for my head, I must say.
Oh yeah, that was. Yeah, it was heavy. It didn't fit my head as well. Yeah, I think Iceland is great. It's so great that I decided to change my name to something that's more Icelandic sounding. I think so my dad's name is Orlando. So I think I'm technically Orlando's daughter. So this is my name now.
Is it even approved by the naming committee?
I
heard
think
they
it
have
should,
a very
because I
strict
went
rules.
right into the website of the list of approved names by the Icelandic naming committee, and I picked the ones that were closely, very similar to my name. So I think that works out.
I don't know, I don't know if you realize, but people here are very tall, and we're not tall.
So
I mean, I'm 158 centimeters on a
Same.
good day, depending on humidity. So I don't know. I don't think we'll be
I think
accepted.
people like
as
to. I don't. Yeah, I
Icelandic.
don't. I think I don't fit in. I think that's part of their citizenship test. How tall are you? Are you at least 170? No, I'm not.
Yeah.
So I just want to post our Twitter again because I want to be Twitter famous like Dan, but also keep in touch with everyone. Because I've really enjoyed all my interactions with everyone so far, and I've had really good conversations with a lot of you. So it's been really great. Please, follow me and Vanessa on Twitter, and let's continue these conversations and, keep talking about JavaScript. And you can also follow my memes. I post a lot of really, dumb shit sometimes. And so let's talk about the party tonight. We're going to Bazaar. And there's buses scheduled from 5:45 to 11 from the marina and here. So let's get ready to party. I heard that there's a karaoke, so I bet like $20 that someone's gonna sing "Don't Stop Believing." Don't even kid me. Like someone's gonna do that.
Oh, for sure.
Yeah,
I'll
or like
bet more than
Mr.
20.
Brightside, Wonderwall, like name it, all of that. Yeah, I just want to. I just want to again promote how Canadian we are.
Yeah, I'm sorry.
We're so sorry
for things we did not do.
Oh man.
Saturday,
so we do have a
community
trip on Saturday, which is great because we get to see Iceland. We're driving down the south coast. It's gonna be from 10 to 6. Oh, is that 6? No, that's 8. I don't know how to read time. And it cut off over here.
There's more info on the website.
Yeah, there's more info on the website, so check it out. And apparently there's been some cancellations. So there's going to be a waiting list that's going to be opening it up at the website. So you can sign up for that if you don't already have a ticket. And then we're also going to the Blue Lagoon for the farewell brunch, and this is the information. I'm really excited. It's been on my bucket list for the longest time. Can't wait to check it off. And yeah, that's us. I'm glad that most people used the nose ring and the earring to tell me and Vanessa apart. Like people will come to us and be like, nose ring, Florida, earring, Vanessa. It works out. So thank you so much to everyone, and this has been really great.
Yeah, you all have been wonderful audience, and yeah, so a round of applause for all of you.
And I'm just gonna call on the organizers to come up on stage because I think they want to say something as well.
Yeah, we really appreciate you flying in to be the masters of this ceremony. Big thank you to you both, and yeah, give them a round of applause for an awesome job. Yeah, the party tonight, this is not over yet. This is like a sorrow moment. Tears are starting to flow out, but we still have 2 more days and 1 night. So we're technically halfway through. Depends on how you look at it. But yeah, we will have all of the info on the website. If you need anything, contact us on Slack. We want to end this like we end every JSConf with a big family photo. I want to begin by inviting all the organizers to the stage, like just to echo what they said without tooting my own horn, like epic job by these people, and really give them a round of applause. And yeah, with that being said, I want to invite all of you to the stage. We will have to move some of the tables a bit away. We are probably 250 or 300 people still in the audience, so it's going to take an effort to put us all on the stage, but the photo will be epic. So thank you all for coming, join us on the stage, and enjoy the rest of JSConf and Iceland. Cheers.
Day by day, I don't know what to do. But I'll try just for you.